It is investigating the maximum baud we can actually run on the UART devices right now, which is interesting.
Religious meditation sound.
Don't worry about it.
I think we said we need it for next Sunday, right?
Yeah.
So I mean, like, no rush, but
Yeah, but
if you get it done early, that's
motivated.
cool. Yeah. If you're feeling motivated, go for it.
Wait, so we do the flight test next Sunday? When do we do our flight test?
No, we have to get it working first.
Oh, true.
Flight tests with zero pilot? That big
I
question?
don't know, I heard there was like a flight test.
So-
Or I might have saw something wrong because I was like scrolling down fast because it was midterm. Like 5 minutes before midterm, scrolling down the channel.
How were you doing that? How were you doing that?
I should reread the chats. I haven't read them so far. And then I just recalled it after
I looked at
midterm.
the chat and I saw some pictures of Annie cooking and I was so confused.
Careful.
Ah!
Oh gosh.
Is any of this ours?
Nope.
So the tripods aren't the Arc 900, the...
Nope. None of it's ours.
Okay. Why is
Even
it
the
here?
black spy plane isn't ours.
Is it here? Is it here just because...
We've been using it to fly this.
But we don't need it anymore?
We will not need it soon, but we need it now because we have.
Wait, Annie, are we gonna keep the new one or are we gonna use the old one to Andy?
Whoa! I can't say anything on stream.
Are we saying on stream?
We are staying on stream so that we can use this later in 3 years
That's the meeting, right?
and wonder why we did the things we did. You're the famous Aiden.
Annie, so you know the new Dragon Link we're getting?
We're not getting a new Dragon Link.
RFD, sorry.
Yes.
Are we gonna give that to Andy or are we gonna keep the new one and disassemble everything and give him the old one? It might just make more sense to give him the new one.
I would disagree on that.
I think there's very clear rules from the SDC on what can or cannot be done.
Okay. Sure.
And I'd say we should give him his own equipment back and we should use our own. It's like, I don't know, that's like buying a new piece of equipment and donating your old piece of equipment that you've been using for years to someone else.
Are there like specific rules against that?
No, but it's like, it's older,
There,
it has been used, there's potential for whatever
Okay.
degradation, like,
Sure.
there are rules regarding like you taking team funds to buy something and then giving it to someone. That's strictly prohibited.
Yeah.
Like you can't buy a laptop for WARG and then
Use it for like your own thing.
just take it for yourself for the next few years, right?
Yeah.
That
Makes sense.
any idea why this is open and all these batteries are on the floor?
it's been there since forever.
Is that a lead acid?
Sure, is today's meeting a continuation of yesterday's one?
In a sense, yes. In another sense, absolutely not. Do you want to move that?
Is this a tripod bag?
Yes. The power, unfortunately. Okay.
Okay, this is a continuation of yesterday, but not really. Did
Yeah.
you watch the video?
No, I don't have time.
That's fine. What's your name?
I'm Hardy.
Hardy?
Yeah.
Nice to meet you, I made it. Are we streaming?
Yeah.
We're live, this has been recorded for the past 5 minutes?
Yeah.
Good. Okay, so you should talk because the video, you were there.
Okay. Do we want to start with So everyone here is at this point, with maybe the exception of Hamza, fairly familiar with Attitude Manager as it stands, right? Where you go like fetch instructions, get position, run control loop mode, and then output mixing mode, and then you kind of just go in a circle, maybe with 1 or 2 extra states, depending on what I forgot to mention. Everyone's clear on that, right? Okay, and so, is everyone clear on what a state machine is as well? Where you're in a state and then you have defined transitions from one state to another state based on events or inputs or some other variable. Yes? Okay. So the issue, or what we've noticed, or what Sahil noticed when we're looking at Attitude Manager and looking at the new flowchart for it for Attitude Manager in Zero Pilot 3 is that there are a lot of states that don't have transitions to other states other than the immediate next state. So you have things like get position, which will always come after fetch instructions and will always go before control loop mode, right? And control loop mode, which will always come after after get position and will always go before output mixing, etc., etc. These don't necessarily need to be states because they, like run sequentially, and there's no reason for them to be states. Leaving them as states leaves you a lot of bloat in your code. You write a whole bunch of classes and enter and exit statements over and over when you don't need to. It also makes it really confusing if you're looking at the code for the first time, which you've probably just experienced. What we all also notice is that a lot of the things in Attitude Manager used to be on Attitude Manager because Attitude Manager existed wholly on the safety chip. So a lot of things like get instructions is not entirely related to the management of the attitude of the aircraft, right? So if you look at any off-the-shelf flight software, attitude management exclusively takes a desired state and outputs how the drone should get to that desired state, right? It doesn't care about things like, are you armed or disarmed? If something else fails, Attitude Manager doesn't necessarily care about that, right? Like if sensor fusion fails, it's not Attitude Manager's job to necessarily check for that and then go into a failure mode because of that. At least not in a very Attitude Manager sense. Historically, it's done that because it's been the only thing that runs on the safety chip. Now that we have more things running on one chip, we don't need it to sort of assume that functionality. And so we run into this conclusion that you want a lot of the function from your Attitude Manager to be moved to something else that sort of manages the entire system of Zero Pilot. So like your system manager, or I don't know if you guys had a different name for it last night.
I think he called it system manager.
Okay, we just sort of call it system manager, and it seems appropriate. Where the system manager handles things like the system state, such as being armed, being disarmed, if you need to go into some sort of failure mode, some sort of recovery mode, or if you need to be doing different things. And then Attitude Manager in that sense goes back to just managing the attitude of the aircraft. It gets inputs, it figures out how to get to those inputs, and it gives you an output that tells you how to do that. And then inside of Attitude Manager, you simplify your state machine a lot. It doesn't even need to necessarily be a state machine anymore. And you just run your code as it is. That is the summary of yesterday's discussion. What are the goals of today's discussion?
I think we want to lay out what the system manager looks like, what attitude manager looks like, what both of them own, what their responsibilities are, and then as well how path manager and sensor fusion fit into this new order.
Sorry, a quick question. So yesterday from a book, Embedded System, I just want to know why we don't put a logging system inside our current system. So if we have a logging, and if we just kind of if it's sensor fusion mode, I just open the global log for it. So each time we just input how the progress is updated to the global system, and each submodule like attitude manager, system manager can take a look at what happened before, so do the pipeline based on that.
I don't know why we don't have a logging system. It's presumably a number of things. It wasn't high enough priority at whatever given time. We didn't have a way to easily write to a log that could be accessed later. Like we, before now, haven't had an SD card driver, so, or any sort of file system driver. So like we could have made an implementation that just logged a whole bunch of data to some large buffer. But then also reading that buffer was not something that could easily be done. I think these are all things that are easy to change in the near future. We now have an SD card driver. We now have a bunch of open UART, so we can actually like dump over the FTDI cables if we want to go that route. If we're using a Nucleo, we can just use the serial interface. Like, we now have options. Last year we didn't.
Yeah.
Sorry, one more question. So when we're seeing logging, why we think log is a very large thing? Can we just say like we make it in mu and each say like if it's rusting, I'm not sure. So kind of like a switch. So if it's on the centrifusion mode, so it just say centrifusion mode is finished. So it, the previous progress and what it do basically just in a single variable, and it can summarize kind of like that. So we make this space small and fast to assess.
I'm not sure why you want a log, why you would want a log that only keeps track of the current state. At that point, you might as well just use a debugger and look at the current state.
Or a light, if you need it
Or
to be
a
real
light.
time.
Or whatever, right?
Yeah.
Typically, with a log, you want to be able to see a log as in a summary of past events, right? You want to be able to see the progression of what happened leading up to an event, and then also information about events.
If you scroll back really far in the firmware channel, you'll see that we actually used to log to the EEPROM of the safety chip. And then you would finish your flight and you would not be allowed to turn off you would not be able to like unplug the power on your chip until you got home to your computer, where you would then read in every single bit of that EEPROM into a really large file and then slowly go through it in like a Python program to get your output data. So we did have logging. We stopped doing that because it's an incredibly huge amount of effort, and it also destroys the chips because the EEPROMs only have a limited sort of write cycle. And we never got an SD card driver working, but you know, we now have an SD card driver that works. We now have the ability for safety or attitude management to talk to the SD card driver, because before, even if we did have an SD card driver, it wouldn't have been on the safety chip, and it would have to communicate over interchip, which is like a whole other issue. And so, you know, hopefully soon we'll get logging, and like I can understand why you would want it, seeing everything we've done today. So yeah, it's in the works, it's in the pipeline, and like our architecture is becoming better every year, just a bit, and it hopefully makes it easier to log and to work with as we sort of build this. Okay. Any other questions outstanding? Okay. If there's anything that you're not sure about, now might be the best time to ask, because we're going to start talking about stuff, and if we don't understand sort of what everything is right now, it might get confusing later.
Did I miss anything yesterday? Because I have 12 sessions.
Did you miss anything yesterday?
I
Other
think
than
I missed the meeting, but it's like, I don't know what happened yesterday.
okay. Other than the 10-minute summary I gave you just now, I don't think we've made significant amounts of sort of discussion progress.
Did we make any progress on the PA, like AEM machine?
That's what we're going to talk about today.
Oh, okay.
So, we had points planned for AM. We realized maybe we want to re-architect AM and do it properly, and now we're here. So, do we draw 2 blocks for system manager and AM?
I think you start with system manager up here. Right? I'm imagining system manager is the top level controller of all things. Like Sahil and I were even talking, I guess this is a good place to start. Does system manager, is it responsible for spawning threads?
Seems logical for it to be responsible for spawning threads.
Like the one thought we had was, I'm gone. The one thought we had was path manager probably doesn't need to run all the time. If we're not
That's true.
if we're not flying autonomously, then there's no reason for path manager to be running.
Okay, let me draw it back out first.
Yeah.
So, how many parallels thread we need? We know sensor fusion and AM state machine is running parallel. What else do we have in the
So-
old architecture?
At the very least, sensor fusion needs to run in its own thread. Or more accurately, it has strict timing requirements, and those timing requirements need to be met. It has to run at a fixed frequency. And that is, I don't know if Path Manager requires its own thread or not. I don't think there's any timing requirements for Path Manager, right?
No, but there's timing requirements for attitude manager.
Yes. So, sensor fusion has timing requirements, will need to be its own thread. Attitude manager has timing requirements, may or may not be its own thread depending on what we decide here. Although I'd imagine it will. It'll probably be its own thread that is controlled by system controller. How about flight controller? Just call the top level class that manages everything flight controller.
I mean, yeah, and like most programs, it's just like if we were doing it the way other programs do it, we would call it zero pilot bus.
Yeah.
I like that. But I'll call it a system manager for now, just so we can stick to system info. Okay. So as it stands, sensor fusion doesn't run as part of zero pilot software, it runs as part of loss. And
Good.
the reason for that is because when we're getting the position from the interface, we want it to always be consistent and we always want to expect just good position data, right? So zero pilot software doesn't care where you got that position data, it doesn't care what sensor you use, it doesn't care how many sensors you use, it just wants the best data it can get, right? And in this case, sensor fusion existing in loss makes sense because we can either go between something like a vector nav, which is going to do sensor fusion for you, or you run your own GPS and IMU and you have to run sensor fusion on your own, right? And so zero pilot software doesn't want to care about what hardware you're running, so we include sensor fusion with Laminar OS. And then inside zero pilot software, we have path manager, which creates our paths, telemetry manager, which sort of communicates the CV and ground side, attitude manager, which handles attitude, and then we're planning on introducing the state manager. Clear. Each block, with the exception of these two, is its own thread at the moment. What are the advantages of threading? Sorry, question?
So do we run FreeRTOS in a system manager?
I think it makes sense to initialize FreeRTOS in main. FreeRTOS then probably spawns a thread that handles system manager. I assume you can spawn threads from threads.
You can.
So I could foresee the main spawning system manager and system manager spawning everything else. Although this is all up for discussion.
Yeah.
I guess that's just sort of was my first thought.
Yeah. I think it's fair that we first talk about why you would want something in a thread versus not in a thread.
Yeah, I agree.
From my understanding, which is fairly limited, threading, the only advantage is that it gives you a timing bound and a specific amount of space to use. Yeah. I don't think there's anything else that it does that you can't do in a regular program. But it
Yes.
has, sorry.
This free RTOS will move the stack pointer between the threads as they're executing.
Mhm.
Right? So you can have parallel execution.
Mhm.
That is the only other benefit, I think.
Yeah.
But that can also just be a hindrance.
Yeah, so the negatives of a thread is that it uses a little bit more resources, a little bit or a lot depending on your hardware, and getting data between threads is non-trivial, especially on the lower level side. But we get mail queues from FreeRTOS, which wraps it up nicely, and we just send them back and forth, and they arrive in our inbox, and we go, yay, we got mail. So, yeah, those are the advantages and disadvantages. So I guess what we're looking at now is we're trying to figure out what in this system might we want to put a timing bound on, right? And let's just go around and put stars on them. So SF needs a timing bound of very high, 800 hertz is ideal.
I don't remember what it was before last year's competition.
It used to be 100.
Well, for last year's competition, we had to reduce it to 100, right?
Yeah.
I can't remember if it was 800 before that.
I'll write in a
Higher frequency, better.
100 question mark. I don't think it works past the 100 because of the math.
Okay.
So 800 hertz. I think AM needs a timing bound.
We need to figure out what does AM do. Like, I think we have to get
Right.
into the nitty gritty now
Okay.
before we can sort of say, like, sensor fusion is well defined. It
Yes.
isn't being touched. Like, it works. We know it works.
Yeah.
We're not changing it, right?
Yep. Cool. These are nice.
I think this is the point where we talk about what exactly does Attitude Manager do. It takes an input of the aircraft's current attitude and a target what?
This is where it gets kind of complicated, because your input could be in acro mode, in level mode, or in GPS mode. For a quad, a plane, or anything in between.
Right, okay, so so when you guys were talking last night, you suggested that Attitude Manager should be in charge of understanding and controlling the aircraft's type.
Yeah.
But Path Manager also needs to know the aircraft's type, right? Or does Path Manager, no. Path Manager, yeah, yes it does for landings.
It needs
Path
to know
Manager
it
is
for
in charge of
landings. So the way it works is that you define the kind of aircraft that you have in the system manager is what we come up with. Like, you have to let the program know at some point what you're flying. And you define that in a global configuration file or something that you can put in somewhere. And you define things like the number of motors and where they are and what kind of protocol you want to use, like D-Shot or PWM. And that all gets sort of just thrown into one big configuration file.
For sure.
And then Attitude Manager, taking that information, has very fine control of the flight mode you're in. Whereas the system manager and path manager care a little bit less about what flight mode you're in. They only care so much about the airframe type. And so you have a default sort of landing and takeoff class with override hooks to go to like extensions of the base class that go for each aircraft type, and depending on the aircraft type, you just choose which one to compile or if statement or however you want to approach that problem. Because your aircraft type is unlikely to change when you're flying.
Okay, so attitude manager takes input attitude and sorry, input of the current attitude and the desired attitude also including velocity.
Yeah, so those, yeah, SF.
Actually, attitude manager, the only thing we care about, I think, from the output of attitude manager is the velocity of the aircraft. Right?
Velocity in what way?
It's direction and magnitude of travel.
As an output from AM?
Well, as an output, as in like
Like
the
as a
outputs are
result
to
of?
yeah.
Okay, yeah.
The outputs are for each of the motors. But just in general, it's input of current attitude, target velocity, and target velocity. That's direction and speed.
Yeah, I guess AM is just like a big closed loop controller, position controller.
Yeah. So like I'm thinking we have an attitude manager interface, which is like the input, command, whatever, and then subclasses or inherited classes that override, like attitude manager interface is a pure virtual object
Yeah.
that all of the different airframe types implement attitude manager differently.
I don't think that's a bad idea. I think the one sort of nuisance you'll get to is when you have to deal with the transition state between, let's say, a quadcopter and a fixed wing.
It's
Good
like
enough.
that, right?
Good enough. I don't know.
There's something in here.
I
So we have like an interface, and then children of this are fixed wing attitude manager, vertical or quad rotor attitude manager, and then for transition state. What if it was just a transition state attitude manager, or like
You would end up
fixed to quad attitude manager?
you would end up rewriting a lot of the codes. Because
What if the fixed attitude manager inherited from both attitude managers? I guess we want to define how do we do a transition from one state to the other for any arbitrary aircraft type.
Sorry, one question. So if we move the main control system to the system manager, do we actually have fetch instruction modes doing AM?
No,
Ah,
because fetch instructions mode would not be managing the attitude of the aircraft.
so it's just control loop mode and then output mixing mode, and that's it.
Pretty much.
yeah.
And at that point, there's no reason for it to be a state machine.
Yeah, it's probably just gonna be like a function, like a while true.
So when we're in one state or another,
Yeah.
we need to be able to transition between them in a graceful manner.
Mm-hmm.
Let's say you're flying in a octocopter configuration and we want to switch to a quadcopter configuration.
Yeah.
And that's the transition state we're talking about, because it's an
Yeah.
easier one than a plane, I think.
Mhm.
How do we do a graceful transition from one to the other? I guess we could define something like a neutral velocity. Because I think the big thing between them, between the various flight modes, is your velocity, since it's the primary output of Attitude Manager, the velocity of the aircraft. We have like a target neutral velocity for all states. And then the goal is to transition from one to the other.
So my question is, when we're having quad, right? Quad is basically when we're at level mode, so we just open the fixed wing, and if it reaches enough speed that can create the lift we want, we just turn off the quad. Is it a smooth transition?
That's the idea, is you spin up the front motor for a VTOL and start flying until your wings are generating enough lift to keep you in the air, and then you also at the same time slowly decrease the throttle to the upwards facing motors.
But if that's the case, they're all at level mode. What's the hardest calculation that we need in order to get graceful transition between? Or it's just keep it level and not open the front wing and then just go forward, that's it. Until the point that it has enough.
It's like this. So if you have the quadcopter control, and then you have fixed wing control, and they both have like PID outputs and stuff, right? But if you go from like this state to here, and then from this state, from this point to here, you might do like some fancy function. Essentially, you mix out one control system and you mix in the other control system.
What if it literally is just take the outputs of both and then do like an average, like 10%, 90%, etc. in the transition over?
So that's for quadcopter and fixed wing. If you have something with like a tilt rotor,
And then is this another management class? Transition manager?
no,
No?
no, please no. I understand what you're trying to do. I just don't think there's enough to differentiate between two different sort of like plane configurations that you would necessarily need to re-inherit a lot. I mean, I guess you're not re-inheriting a lot, you're just, a lot of it can be the same and have base declarations.
Fixed.
Yeah.
Sure. You can have base declarations, override them as appropriate. Sure. Not a pure virtual class. That's fine. This is like manipulating control surfaces and the forward throttle.
Yep.
This is manipulating the throttle of various motors to give you different pitch and roll.
Yep.
Those seem very different to me, and I guess the algorithms that control them will be, for the most part, different, like the control algorithms.
Yeah, so I would say that the biggest difference that you're going to run into is not necessarily between plane modes, because you just define the plane, like you run one kind of control loop, right? The more confusing one is when you ask your attitude manager to, like, let's say you're in GPS mode in a plane. Your plane's flying in one direction, and you're basically setting a point that you want to fly to at some distance, and it's going to target that point. And then going between that and your regular sort of acro mode plane control seems more of a difficulty in making generic than like what configuration?
Going back to the idea of like a transition manager. What if we have a transition manager that's a templated class that takes two states, fixed attitude manager, quad attitude manager, and runs the attitude managers for both, and then handles mixing, like a percentage mix. And I'm saying, I guess what I'm saying here is that attitude manager isn't what directly controls the motor outputs, but attitude manager, its API returns the motor outputs.
I think we have the same idea, but I called mine controls instead of attitude manager.
Okay.
Because attitude manager to me also needs to include the output mixing.
Right.
So I called that one controls.
Okay. So we have attitude manager, which takes those inputs, and then there's controls algorithm object. So replace AM with controls.
Yeah.
Okay. Have we lost everyone yet?
Sorry, one question. So if we can do quad, in quad we can do pitch, roll, and yaw, right? Why we can just replace a flag by using quad that we can say we use the motor we have to like do pitch, roll, and yaw. So we don't need flag control system, but instead we have a quad which when taking off and landing we're just at full throttle. But when that normal flight, like in the pass manager, we just do those reduce, those add, go down, pitch, and if these add, these go up.
So if I understand what you're saying correctly, you're thinking use the quad rotor motors
To replace the
To-
flags.
to replace all the control surfaces
Yeah,
of the
so
aircraft.
control system we only have one, we don't need two.
So two issues I see with that. The first is that doesn't sound particularly, I guess, aerodynamically effective. It sounds like it's gonna be unstable as hell. And like, you're just gonna be fighting the aircraft and like fighting the wind as opposed to doing, I guess, the manipulations you want, right? Because basically you're gonna have a giant wing that's providing lift, and then you're gonna try and provide even more lift to pitch one way or the other. It doesn't sound like it would work. Maybe it would, but it seems weird. But I think the bigger issue though is we want to keep this generic so that we can fly a plane on it, we can fly a quad on it, we can fly a hybrid VTOL on it, we could fly a helicopter on it, we could fly a race car on it.
No. Unironically though, there have been competitions where you have to land your drone, and then you have to get something to drive it somewhere. Like you have to land the drone, you have to drive through something, pick something up from like inside a bridge, and then bring it back out without, flying the drone. And in that case, genericness?
Yeah.
Yeah. Like,
So, like, I get where you're going with the idea, but I think it's important that we don't only consider this year's competition. We consider what next year's competition is, and we don't know what it is. And hopefully, if we do this right, TM, then it's not very difficult to adapt the system for next year's competition.
yeah. So
At which point, it's too easy and we start from scratch.
no, I don't know what you're talking about.
Oh, is it picked pilot?
Okay, so
I'm going to erase this because it's not attitude manager anymore, it's
Yeah.
controls. And these are just controls algorithms.
So attitude manager, AM, is going to, one, decode instructions.
No.
It needs to know what control it's in.
Can AM just receive data from SM, so SM decode all stuff
Yes, I
as
understand
in-
what you're saying. Instructions. Got it. Yeah, so attitude manager needs some sort of instructions for itself.
Yeah, I guess instruction processing, pre-processing.
Sure.
Two, controls.
Sure.
Three, output mixing.
Makes sense. I think that's it.
Does it need to do anything else?
Don't think so.
Not really. Okay.
Output mixing is where we figure out what algorithm or how much of what algorithm we're using.
Yeah.
Controls is the various aircraft types have their own controls. Instructions processing is getting instructions from this guy
Yep.
and converting them into the control algorithm we use and the output mix that we run.
Okay.
Is there anything else that we need from that? No, I don't think so.
Not strictly if attitude management, just handle attitude management. Because your instructions are there, like your position's there for you. Your instruction, once you sort of choose what state it's in, will tell you what you want to do. You run the appropriate controls, you up and mix it, you're good to go. Bob's done. Okay. Now, is there anything in here that needs to be time limited?
Time limited.
Yes.
Well, controls needs to run at a fixed frequency,
Okay.
right? If that's what you mean by time limited.
Yes, that's what it is. Time dependent, frequency dependent.
At least of my understanding of controls, which hasn't changed a whole lot since May.
No, it's better if it runs at a fixed frequency.
Is it possible if it doesn't?
Yeah, but if you're integrating and deriving using approximations at certain points, it would be better to approximate at equidistant points. Because either your integration and derivation is very off, or you run a much fancier algorithm that takes so much more compute that it's almost all worth it. Cool. Okay. So, you know what I'm thinking?
What do you think?
If you put controls in a thread, oh no. I mean,
Tell us your thought and then tell us why it won't work.
okay, if you put controls in a thread that runs at a fixed frequency, it'll just grab the most updated version of this, and this will always just get the most updated version of controls it ever reads from it, right? Theoretically, if you do this correctly with the threading. And so that means that controls gets to run at a fixed frequency, and you can sort of turn off and turn on threads as you need to, because you don't actually need to controls to run for more than, I think, 7 or 8 cycles to get a good value out of it. So you could start or restart, or you could leave both of them running at the same time for like implementation details. And then you do that. The part I'm concerned about more is, do we want something spawned, but do we want this to be allowed to spawn threads?
Well, I don't think it has to. I think it just needs a reference to the thread, the communication point. My bigger concern is controls runs at a fixed frequency, but controls might have said like, this is the output we need, and then output isn't running at that same frequency. So then there's suddenly a mismatch.
That's what happens right now with D-Shot. Because D-Shot runs at like a much higher frequency than our controls loop does.
Okay, I was actually imagining
The other
the
way?
case where output mixing runs at a lower frequency of controls.
I think that's also fine. That's kind of how PWM works. PWM runs at 50 hertz. And a lot of things run faster than 50 hertz in the controls world. And it works okay. So are you suggesting these two together?
I was almost wondering if that should be the case.
If that's the case, then this entire thing should be together, because the same issue that you could have with the output mix not syncing, this could not sync.
Yeah. And then then the issue becomes sending instructions. It just uses stale instructions for a while. Perhaps.
Yeah. I think at some point you're gonna just take stale stuff.
I think that's, yes.
Um, I think the
Where-
easiest solution.
Where is the stale stuff the least issue?
It's better to have an old instruction than to have an old output mix. Because one small miss in this could lead to a much bigger return loss, and then it just induces badness. But if you miss a stale instruction, then you're gonna keep wanting to go that way, but you can still stabilize yourself. So
Stabilize to the wrong instruction.
yes, you go in the wrong direction, but you'll stay stable.
Yeah.
Versus going kind of the right way but being unstable. That's what I think, at least. So these two together
Sure.
in one thread, I guess. So I guess you would run controls and it would also run.
Well,
the
the whole
output.
thing, the whole thing's its own thread, right?
I think.
Because instructions comes from here.
Yes. Okay. So then this one here does also turn into a thread. Question.
How high is D-Shot? 1000?
D-Shot 150 runs at 137.6 hertz or something.
150 is what again? Do you remember?
It's like bits per second.
Right, and the frame size is like 16 bits.
Yeah.
Yeah, so you can do the math on that. But D-Shot, and then the name of the protocol, so D-Shot 150, 300, 600, or 1200. That is, the number is the number of bits per second in the protocol, and then each packet of the protocol, or each frame of the protocol, more accurately, is 16 bits long. So,
With some checking at the end.
I thought the CRC was part of the 16 bits.
Yes, so like your data is not, doesn't matter, you can just Google it later.
Okay.
But D-Shot 1200 runs at 800 hertz, I know that for sure.
But I don't think we're doing that. That's so fast.
So for the one on the AM state machine, so that's it comes on this page. So if we do like control 20 at 20 per cycle, and then output mode like offer it 25 for each, so it have a 5 of a gap, and it just continuously sending the same data during that interval.
Yeah, so basically how it'll work is you have controls. If the way if I understand the way you're describing it, you have controls here, and update here, 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 and here, right?
Yep.
And then you have output which will update here, here, and then like here.
Yep.
This one will grab this data, this one will grab this data, and this one will grab the preceding data, right?
Yes.
It's yeah, and then like at some point it'll sync up again and it'll desync, and it'll sync up again and it'll desync. But at some point you're going to be grabbing fairly old data in time.
I think it will be nearly impossible to not grab data that isn't a few hundred microseconds long or old.
Yeah.
I don't know how long we'd need to, or how old a piece of data would need to be before it's considered stale, but I don't know, I'm imagining anything more than like 50 or 25 milliseconds is stale kind of thing, then hopefully we're not getting there.
I think 1 PWM cycle would be stale.
50 hertz is,
0.02 seconds.
so what's that, 20 milliseconds? So yeah, about 20 milliseconds is stale, sure. That seems reasonable.
And like most of the time, even if you're a little bit old, you're never gonna notice it. We're just trying to prevent it if we can.
Minimize it in the data pipeline as much as possible. Yeah,
Okay, so AM is a thread.
sure.
Cool. But it's not a state machine.
Correct. All it's doing is executing those 3 events. That's what they'll call it, right? An event loop.
Yep.
Non.
SM event loop. Non-integral M event loop.
So if we use linear approximation more instead of derivative more, will that help to increase the speed of the calculation?
Yes, it would, but we are using linear approximation, unfortunately.
Sorry, a linear approximation of what?
The idea.
Hi guys. I'm no longer tall. Okay.
Attitude manager is its own thread. Excellent. Well done. Go teams. This.
And we've actually figured out very nicely what attitude manager wants to do, and very nicely what the controls is going to look like.
Yeah. Does anyone have any questions or thoughts or disagreements?
Just have a little question about fixed frequency. Does that mean we're just using a fixed amount of frequency for program, or do I understand wrong?
You are understanding correctly. So basically, the thread or attitude manager will run. For example, if we want to run at a fixed frequency of 50 hertz, every 20 milliseconds,
Yeah, it has
we'll
to.
expect the new or the loop to restart.
Yeah, so we need a timer for attitude manager, right? It has to execute action for every single 20 milliseconds of cycle.
So there's, I guess, a few points in there. If you're talking about timer as in like a hardware timer that you would find in an embedded system that fires an interrupt, is that?
No, it's just like an attitude manager. You ask at the last process, has the this amount of time passed, and if you say no, you just go back and then.
Oh, the old attitude
I
manager.
should,
Oh.
yeah, we should get used to the diagram.
So no, this is good. This is good. So, basically, that's what's going to happen.
Okay.
I think the mechanism is probably going to be slightly different because that attitude manager is in a more simple system, and then also had to do a bunch of other things, which is what we're trying to avoid. Basically, it would, I assume it would poll the real-time clock and just ask,
Oh.
have we gone past our expected start time, and if we have, then start again.
Oh, okay.
What we're probably going to do is using free RTOS, it has those timing capabilities baked in.
Oh.
And basically you'll put the thread asleep until it's time to start up again. And then free RTOS will manage that for us.
Sorry, I haven't learned thread in ECU yet.
Okay.
Does that really mean like sequences?
So a thread is, I'd say, on a computer,
Yeah.
like a normal computer that you'd work on, a thread is basically just a set of instructions
Oh.
in a program.
Okay.
So when you start up, like if you open an app, I believe the terminology in Windows is, it will call it a thread. It's basically, this app is running in its own thread, and Windows is managing it and making sure that it isn't hogging all of the processor's time, right? And then you have multiple applications that all run at the same time. And the reason they can do that is because they're all on different threads. And the operating system is in charge of giving each application some time on the CPU.
So thread is like initializing, like instructions?
So it's not initializing, it's sort of, imagine having multiple processors
Uh-huh.
and being able to, like, if you were to just like write code for an Arduino,
Uh-huh.
and you try and run it, you can't run instructions at the same time, right?
Mm-hmm.
So that's what threads allow you to do, is run multiple different things at the same time.
Okay.
Yeah. And it's not technically at the same time because the operating system is basically just switching between them, but
It goes so fast that it almost looks like it happens at the same time?
basically, and it will make guesses as to what the most important thing to do is based on what you've configured.
I can tell it to just let one thing run forever.
Yeah, and then I guess the other thing is it can also just, a thread can run forever by itself,
Mm-hmm.
or it can run in parallel with other things.
So it's a loop forever?
It doesn't have to be, but that's usually a common implementation is if you've got, I think they're called long-lived threads. Basically something that's gonna live for a long, like attitude manager is just gonna run in a loop, right?
Oh, yeah.
And so in that thread will just be that loop, and it's gonna execute that all the time.
Oh, so thread contains the coding in it, right? Our
Yeah.
coding, our process
Yep.
for that, okay.
Yeah.
And each application has its own thread, so we can run it almost at the same time.
Sort of the idea, yeah.
Yeah. And in a computer, each application would probably have its own thread.
Yeah.
In this case, in our case, there are some things that we don't really put explicitly put in a thread, but
Mhm.
has to, everything because we're using FreeRTOS has to exist as a thread of some sort, but there are some things that can exist in sort of one big thread that's not a very high priority, and there's some things that need to be very high priority, or that you want to put a fine timing sort of
It
limit
seems like
on.
it's just a single thread and then it's like a thread that runs in parallel. What are the differences?
Basically nothing.
Oh.
The idea is it should be seamless to you as the person developing it. They should work the same. Under the hood, FreeRTOS has to do the operating system has to do a whole bunch of things. Like, it's keeping track of the stack space for each of the individual threads because you have to allocate a certain amount of memory
Yeah.
for each thread. It keeps track of where the instruction pointer is for each thread, which is basically where in the code you are. And so it's like it manages multiple things all at once, but for you, the programmer, you don't really have to worry about that. You let FreeRTOS, you let the scheduler, you let all that stuff do its work for you.
Or if you really love programming, you do it yourself,
Or that.
which we will not do for some reason.
We are not that good.
Not that good. But yeah, I drew a diagram. It's not super accurate, but
And
and execute SF and then PM. I just didn't write the execute part. And then in this case, SF has the most priority, and so when SF wants to run, other things sort of get moved out of the way for it. And the timescale is very wrong, but yeah. You check.
Yeah, my question will be if AM receive a data from SF, right? And after the next cycle, PM get a different data from SF, but it's slightly different because AM is executing. Will that make a difference for us to?
no.
No.
So hi Anthony.
Hi. How are you doing?
So on the timescales we're talking about,
Yeah.
it's barely gonna be any different at all. Like, we're at the slowest, I think. We're talking 100 hertz probably.
Yeah.
At the slowest. Which means what's that, 10 milliseconds?
Yeah.
And sensor fusion is calculating the aircraft's position in space. How fast can you rotate a drone in 10 milliseconds?
Not a lot.
Well,
Like,
a decent amount, but because you recompute every 10 milliseconds, it doesn't end up mattering, because if you don't get it this time, you'll get it next time.
yeah, and it's like, this might be 10 milliseconds ahead of this or whatever. But this, it's not that big a deal because it's gonna be pretty close,
Yeah.
and then it's gonna get what this had, or something
Also going to
close.
follow with that, the idea is that these modules work independently,
Yeah,
right? So attitude manager, its one job is to keep your drone in the air the way you want it to, right? And path manager is going to tell you where you want to go next, right? And so if you miss an instruction from path manager, you're just going to keep going the direction you were going in a stable way for another 10 milliseconds, which is, like when you're in a stable state, not very far. And likewise, if path manager misses something from attitude manager, in 10 milliseconds it'll update anyways, and it can just recompute, and it'll be okay. The 10 milliseconds is only really a significant issue in the actual stability of the drone, because in 10 milliseconds, a lot of random events can happen. Like, 10 milliseconds is like the upper bound of how fast you want your robot control loop to run when you're doing ground-based robots, when they're moving fast with a lot of power, because anything higher than that, and you won't see small oscillations that you want to cancel out.
The next question is, you're right, SF is running at 800 hertz. Is it excess or waste performance in that kind of sense if we're at 10 milliseconds?
No.
Why?
Integration. Integration.
it's doing math, and then providing an output. Because it's doing a bunch of integration, the faster we can run, the more accurate our data the output can be, basically.
Oh, SF is reading not from raw IMU
Yes.
each time.
Sensor fusion reads from the IMU every time, and then generates an output.
Yeah.
The faster it can read and perform new calculations, the more accurate the output will be.
Oh,
Yeah.
So the output might be generated faster than anything else can use it, but it will be more accurate. Does that make sense?
yeah.
If you actually look at SF math, it's really cool. It's got this integration before gradient descent, and basically the more times you integrate it, the smaller your error becomes. Because it takes the previous error, this error, and it predicts the next error, and by doing that prediction over and over, it minimizes the error, throws it into gradient descent, and then slowly your error bounds decrease. And at some point they'll increase again, but that's at like 20-30 minutes. But like it does a lot of very fancy math, and it's really cool. And we didn't come up with that because we're not that smart, but it's really cool. You should take a look at it. Yeah, so fast is good. But like if you run AM at 800 hertz, there's probably no point, right? Your motors don't run that fast. You're not going to see any sort of noticeable improvement in control performance on a quadcopter of our size that fast. So yeah. Any other questions?
Actually, add something for the graph you just draw. Yeah, you erased that, but is that graph for the ties arrangement for different kind of parts modules, or it's?
Yeah, the graph I drew was not very good. I'll redraw and explain what I'm sort of thinking when I draw it, right? So your CPU has a set amount of time in some time block, right? It can only do so many processes. And so you have your different threads. And in this case, the number of the thread is going to correspond to, let's say, its priority,
Yeah.
right? So if my thread is priority number 1, I want it to run when it needs to run, right? Let's say it's like this. If my thread number 2 needs to take this long to run, it'll just get chopped off when it doesn't get to run, and then like it'll sort of just get extended when I can. And then same thing and so on for other threads. If thread 2 and thread 3 are the same priority, the processor would split time between the two, and you would see it sort of like tick back and forth while thread 1 gets to run whenever it wants to, because thread 1's the highest priority and is the favorite child and can't do anything wrong.
So when you're saying they can run parallelly, they are not actually running at the same time, but you're kind of insert some task into the gap of while it's running some other.
Yeah, it's like you're eating dinner while watching this presentation. You're gonna eat your food for a second, and then you're gonna go back to listening. And then you're gonna eat your food and go back to listening. Right? And if like the presentation is more important, you're gonna eat food slower, and you're gonna spend more time doing a presentation. But your food's really important. You'll eat your food first, and then you'll like listen to the presentation when you can.
Yeah.
Something like that.
Well, I mean, it clicked at like 2 different heads immediately when you said that. That was good. I like it.
Is FreeRTOS running at the same level as Hall Library, or it's running at the same level as Loss Core?
Below Lost Core, I think, but above the HAL.
It's almost the same as loss core, depending on how you describe loss core. It basically just manipulates the HAL.
Yeah, there's a bunch of HAL calls in FreeRTOS that you can, if you wanted to, you could look at.
And edit if you really wanted to do something that you can do.
Yeah, you don't edit those. Unless like things are broken and it's the last week before competition and you can't figure out why things are broken.
Oh, assistic timer.
Oh my gosh.
Okay, so we've determined SF and AM need to be threaded.
Yeah.
And we don't want any of those to necessarily be the main thread. I think SM owns the main thread, or is the main thread.
I think SF is pretty obviously a long-lived thread that loss manages, right?
Yeah, like we don't actually want to know about the existence of this because we might not run this at competition depending on the vector map.
Right.
So we can't put something. No.
But that thread
Mhm.
is going to exist, and
Yeah.
this will not know about it. So there's going to be 2 threads that are spawned at the start of the program.
That's okay.
Yes. But I think you said like this was the only one.
Oh,
But-
like main for 0.
Got it. Okay. Yes, I think this one is the big boy, head honcho.
Boy.
Big boy, head honcho, main ZP thread. Yes, sir. Okay. Do we want to talk about path and telemetry manager?
We probably should.
So I don't really know how path manager works, like at all.
Okay.
I know there's a struct that it outputs.
I don't want to erase this, so move on. Ah, it's a battery. I don't want that. I hate the metal things. Move them. Get rid of them. Destroy them. Okay. So maybe monolithically we just put them with the mech stuff.
We're advertising to YouTube now. You should join. Go to WARG.com.
Oh, okay. Yeah, I'm really sorry. Actually, let me see this side. Do you have chalk?
No, this I don't think is actually a blackboard.
No, it's Blackboard.
It's a blackboard. Do you have chalk?
Okay, well, it didn't work out so hot when we were trying to use it. Just use the whiteboard side.
Okay. I'm really sorry.
We can draw something new at the
Yeah.
end. Like I mean, look, it's already like mostly wiped off.
You can
Who
advertise.
who wrote this? Was it Jenny?
Jenny wrote a few of it, and then Christina drew all of these like little things. And then
Well,
someone random drew that one.
We now have evidence of Anthony's crimes.
They weren't crimes. Oh, these are the nice ones. whoever bought these are
Yeah,
genius.
but you missed a little spot on the left. Bottom
Oh,
left.
ridiculous.
It's
An
gotta
unfinished
be,
job.
it's not in the middle left.
I think someone used a permanent marker.
Bruh.
Or it's a tape or something. I don't know, whatever. It's okay. Not interested in taking it. Okay. Does that show up
Yes.
on there?
Oh, you're recording this.
Yeah.
Oh.
Yes.
Okay,
I didn't
perfect.
know that.
So, path manager. My very limited understanding of path manager.
I'm the student of
Can I
this
just
one.
go through all the separate managers?
Well, we're trying to figure out what needs to be threaded so we can write system manager this weekend, or so that he can write system manager this weekend.
Ooh, Aiden, woo.
What, are you writing it?
I'm gonna write a bunch of stuff. We'll see what exactly that is.
Yeah, don't distract him from this stuff. Don't do it. If he doesn't do this properly, he's just gonna yell at me for the rest of time forever. He's just, oh, but Anthony, we could have done this, and it would have just been so much nicer if we used like function pointers.
No, we don't want to use function pointers, right? That's what the hill said, right?
Yeah, we don't want to use function pointers. Dangerousness. Okay, path manager. One.
Did they
That-
decide list of waypoints versus single waypoint?
List.
List of how many?
All. Or. I think what they defined was like a link. What I talked to Neha about was you get a linked list style thing.
Right.
So you just go next or previous, and then you can convert that to a single one or as many as you need for path manager to work effectively. Because no matter how many points they give you, you'll just I should probably throw a few more points in there to make this realistic. You'll just assume that the last one you have is going to be your landing point, or like a hover point, or whatever you want to define it as. And then as you fly through, you start defining more points in the future, and you just move where you're going to hover. And in that way, if they only give you one waypoint, then you'll just fly to that waypoint and then you'll hover there, or you'll circle there, or loiter, whatever. But if they give you multiple, then that means you can actually generate something very nice and useful. Especially if it's like, you need to do like this kind of thing. It'll be a lot easier to fly this way than to like fly here and then fly here. Because sharp turns are really difficult on a plane. Okay. This one can stay in speed. 1, get waypoints. 2, get position. 3, path planning. 4, up. On a very simple generic level, this is what path manager does. Thank God it's not 10 points. You get your waypoints, you get your position, you do your path planning, and then you output to AM, to TM. Right? And then your waypoints are from CV, or maybe from the ground if we've made waypoints on a map.
Okay. More accurate to say from state manager or from system manager? And system manager,
Yes.
Okay, so system manager is, takes input from whatever ground station or,
so system
CV.
system manager is gonna be the big overarching control thing. It is going to tell all of the different modules in ZeroPilot what to do. And it will be responsible for like, it will tell attitude manager, this is where we wanna go. It will tell path manager where the waypoints are we wanna go to. It will manage whether or not we're in a disarm mode or a failure mode or that sort of thing. it's sort of the big boy head honcho.
Main ZP thread.
So it takes the SF output and then just do whatever things with it?
I'm not sure system manager will
I think
need
it,
it.
I don't know, because it says waypoints for like sensor features?
Oh,
oh no. Waypoints are spatial coordinates
Uh-huh.
defined as latitude and longitude and altitude.
Uh-huh.
And you'll have a list of waypoints as well as the type of waypoint. So I can have types of waypoints like cruise, hover, circle, and I think landing and takeoff. And so Path Manager will take those waypoints as places it wants to get to and what it wants to be doing at those points. And it'll create a path, or it'll get it where it is right now, and it'll create a path to go through those waypoints and do those things. And I guess that extends to landing and then driving on the ground. I guess it would, like taxi. We had a taxi movie. And then it'll output to probably Attitude Manager, maybe through State Manager? I don't know. FreeRTOS milk queues. Or Path Manager doesn't need to be a thread. It can just be inside SM because SM doesn't have a time limit on it.
so Path Manager doesn't have any time, doesn't do any timing calculations, or doesn't have any calculations that are time specific, or time dependent rather.
I don't really think so. I mean, like,
So if it does its current implementation run in its own thread?
yes.
So it's running in a loop, I assume,
Yeah.
going through these steps. Where does the output go? Or does it just like hold on to it until something asks for it, basically?
It sends it off in a mail queue to AM and Telemetry Manager.
Okay.
And I think in the current implementation, Telemetry Manager and Attitude Manager together both have some parts of what you would want System Manager to be.
So the only thing that I've been thinking about with mail queues,
Yeah.
you have two threads that run at different times,
Yep.
but each of them, so let's say Path Manager runs at 20 hertz and Attitude Manager runs at 10. Not that this is a realistic scenario.
Yeah.
Path Manager will be filling up this queue, and Attitude Manager will be reading from the queue slower than Path Manager provides output. Does Attitude Manager empty the whole queue? Does the thread empty the whole queue every time it tries to read?
Yeah, I think it's a queue, but it's not really a queue, it's more like an inbox. It's just a buffer, and it reads from the buffer. Well, that's how it's been described to me. And so if there is new data, it'll be new data. If there's old data, it'll be old data.
Okay.
Interrupt-based scheduler. He did not like the idea. Hey, I got new data for you, EM. Oh, cool, let me handle that.
Attitude Manager just grabs it and saves it. Yeah, I think mail queues make sense. I just don't know how they work. So,
That's me too.
anyone
how
know how
this-
mail queues work?
What queues?
Mail queues.
And not like lining up at the post office to like deliver your packages.
Queues? Yeah, I've never heard of that. So.
Okay.
Okay.
They're basically new like semaphores. So are you guys aware of what we call a race condition?
Or race condition?
Race condition.
No.
Siri taught us.
Sorry, who?
Siri taught us.
Ryan's presentation had
I couldn't understand. I couldn't decipher. It was like well, anyways, Ryan. Or you can use his Chinese name, or you can say Zyraming. Zyruming.
Oh,
Xyreming.
Oh. Oh.
Do you want to do the proper pronunciation for us?
I don't know.
Xieru. XIERUMENG.
谢入门。
There you go.
Yeah.
门.
I don't think he even knows how to say it, is what
Yeah.
Ray said.
He tried in the car a while on the competition. No, what the proper pronunciation is Zai Ru Ming. Okay? Zai Ru Ming.
I think he does it to shitpost and upset every single native speaker.
Okay, race condition. So let's say I have a program and I'll run it from top to bottom on this side, right? So pretend we have a timing scale on the side here, like 1, 2, 3, 4, 5, 6, 7. Cool. And then I have thread 1 and thread 2. And the way I used to explain this was using the state machine, because that's how it was taught to me, but I'm gonna try to do it this way. And you have some object straight in the middle, that's just the ball, right? So let's say thread 1 runs at 3 hertz, or like every 3 cycles. So it'll write to the ball, and then it'll write to the ball, and it'll write to the ball.
That's every 2 cycles.
Oh, no, okay, well this one's gonna write every 2 cycles. It'll write to the ball, and it'll write to the ball. And then this one, let's say it runs here, it'll read from the ball, and then it'll read from the ball, and then it'll read from the ball here, right? When this state happens in the middle, you don't necessarily know if you're going to write or read first. And that's what you'll essentially call a race condition, because there's a race for the data. And so if the data here was, let's say, 3, and this one was 2, and this one was 1, here you would read 1, here you would read either 2 or 3, or maybe like just nothing, depending on how this works. And then here you would read happily 4 again, right? And this is a condition you don't want. Because if you're flying a drone and all of a sudden you read a very big number, your drone's going to do something that's not predictable. And unpredictable things will generally crash to the ground. So in order to prevent this, when you're in this state, you can actually do something where your write will lock the data first, it'll write to it, it'll unlock, and then when you're waiting for the read, you'll wait, it's unlocked now, and then you'll read from it, and you'll get your data. You can do it the reverse way, where you read, your read locks it, and your write has to wait for the read to finish before the read unlocks, and then you can write to it, right? And that's essentially semaphores in like a very bad 10 seconds. Mail queues do this automatically. You write to it or you read from it, it'll just, depending on how you configure it, give you the older data or the newer data. It's not going to give you a jumbled mess of in-betweeniness. Clear?
Sorry, when Seeger talking about it, it's more concerning on a security part of it. But when we're doing it, can we just add a flag saying that the data is being modified or not based on that value? We just do that because it will be way more faster than no queue.
I don't know about the speed part. Mail queues, usually code written by someone else is better than what you can come up with on your own, because usually it comes from like years of experience of writing that. Adding a flag
and many eyeballs and improvement over time.
Like the basic idea started as a flag, and then they got better and they sort of added like hardware components to help you do that, and then they come up with better ways to manage it and like unique ways of storing that data to be accessed in like 2 buffer arrays or like, anyways. Mail queues are very nice. I don't know if they're actually faster, but when you do your own bit locking, you can run into a lot of issues where if you have more than 2 threads, one thread might lock it and then another thread might sort of just be stuck waiting forever, because as soon as this first thread is done unlocking it, some second thread locks it again and is waiting for the third thread to sort of access it. but the third thread never gets to access that point because the second thread has never unlocked it. So your program just bricks and stops working. There's a lot of these instances and situations that can happen when you sort of do this yourself. And so typically, you want to use something that's sort of designed for the purpose of transferring data between processes because it'll get that data there every single time. But you also just want to be pay attention to locking, unlocking, and blocking statements inside of threads because you can never get past them. Make sense? Yeah.
Cool. I have a question. What's the difference between a mutex and a semaphore? Because they're very similar as far as I'm aware, but I've never been taught either actually.
You've never been taught either?
No. We don't do programming. Yeah.
Okay. From what I've understood from my sleeping in class, we were taught this and I slept through it, so that's on me. A mutex is the sort of flagging process to exclude certain areas of your code. The semaphore is just a piece of data that can't be used up to 2 times. From what I understand. You can quickly Google this. I should really stop sleeping in class. I'm finally learning important things. I'm still sleeping in class. Anyways, okay.
You still have that question?
Yeah, what's up?
No. Did Aiden still have his question?
I think so.
You care to explain?
Sorry?
What is the difference between a mutex and a semaphore, Sahil? Go!
Okay, so, really simple. Mutex is, okay, depending on how you define it, a mutex is actually a case of a semaphore. That's how they're similar. So, put simply, a semaphore is a way of signaling between threads, all right? Now, the thing is, the difference between a mutex, so all you're doing with a semaphore is it's just signals. You're just firing signals off. A common way of doing something could be say you receive an interrupt button pressed, you fire off a semaphore. Okay, it's referred to as feeding the semaphore in some cases, being okay, sweet, firing off a semaphore. I'm going to increment the semaphore, do something to it. You're sending a signal out to the kernel. Now, the reason you use these signals in real-time design is when you fire off these semaphores, other threads that are subscribed to the semaphore or waiting on a semaphore can be activated immediately. So let's take the example of a button that's like an e-stop. If you fire the semaphore on to basically signal this very high priority thread that is blocked on the semaphore, when you signal the semaphore, the very high priority thread can now run. It's no longer blocked by the semaphore because you've just signaled it. And so what the kernel can do now is it can automatically jump to that task, which is what makes it very critical for real-time systems and a very key concept. Because now you can now assert that when you press a button, your very high priority task that kills everything in the system runs very predictably fast because the kernel stops whatever it's doing and switches you over into this new thread that deals with this behavior. Simply put, the definition is a semaphore is just a way to signal between threads. There's a few different types. There is a counting semaphore. There are binary semaphores. Queues are actually implemented on top of semaphores. You can think of an implementation where when you add stuff to a queue, you feed the semaphore, and then the receiving end of a queue takes from a semaphore. It's helpful to Google, if I had something to draw out, it's helpful to look at diagrams where you have threads or producers and subscribers that actually increment and decrement semaphores. But simply put, that's all semaphores are. They just signal between threads, and it's the kernel's implementation of doing so. A mutex, on the other hand, some consider it a subset of a semaphore, some don't. But simply put, a mutex's application is to protect data, and the key thing that separates it from a semaphore is that it has ownership. A semaphore does not have ownership. What does that mean? Well, when you're in a mutex, you care about what thread is locking it and what thread isn't locking it. That's not the case with the semaphore. Any thread at any time that wants to can theoretically signal a semaphore, but not any thread can go in and just simply take a mutex if it's already locked by another thread. So that's the key difference between the two. You can implement a crude mutex using a semaphore, and all you'd be doing is you'd be giving the semaphore ownership, which is all a mutex is. A mutex is a binary semaphore with context of ownership. It knows what thread has locked it, and that way, when you try to unlock it from another thread or you try to take it, it knows that this is not the thread that tried to unlock it or lock it, if that makes sense. And that's Crash Course to mutexes and semaphores.
You can't see us, but we're giving you a thumbs up.
Sorry?
You can't see us, but thumbs up.
You're not streaming the video.
I can, because you can only have one thing accessing the video at once, so it's going to YouTube and not Discord, which
You can't stream from OBS to Discord.
probably,
Doesn't matter.
would it break my laptop? Probably.
Cool. Thanks for the help.
Thank you, Sahil.
How long have you been listening in?
You know,
Say again.
He's gone.
Is he actually gone?
The ghost appears to
To
tell me that
Answers your question, disappears.
Aiden doesn't know something.
Legend.
Wait, Aiden, do we learn mutex?
You might if you take a course in 3B.
Do we learn data segmentation?
No. Like maybe some of this stuff will come up in like data structures and algorithms. But
It'll come
if,
up in EC 252.
if
252?
if the curriculum has not changed for the courses, then you will not be learning about it.
It's okay, you can learn about it here with us. Have fun together.
Or come to my lecture, you know?
Yeah. So much fun.
This is becoming a common thing. Friday night lectures. Friday night lectures with WARG.
It's not that bad if every single Friday night we have some sub-team come in and talk about something.
I think there's many people who would object to spending their Friday nights in the Bay, but
Free Timbits. Have a good insight.
Hamza called me out last week at the systems integration meeting for not bringing Timbits because I brought them to the first meeting.
Oh. No, you can't bring them to the first meeting. You have to bring it to like some random meeting halfway through the term. Some people who like haven't come feel bad and they'll come next time, but you won't have Timbits. But then you'll just like randomly bring them in again when like you feel like it.
That's a gaslighting.
Okay, so
Back to this.
yes. Do we understand path manager?
Yeah.
Or like the basic idea behind how it functions?
But we were on the question of
Does it need to be threaded?
yeah.
Does it have
Is there
time
any sort
requirements?
of timing requirements? That's the thing I do not understand. Is Neha available or Gordon?
Yeah.
Can we get them to join the call?
Okay, so there's always a timing requirement when you're in a real-time system. Sure. I think the question we ask is what happens if sensor fusion runs a little bit slower than it needs to, and what happens if sensor fusion doesn't run, or not sensor fusion, path manager runs slower than it needs to, and what happens when path manager doesn't run at all. So, in the case that it runs a little slower than usual, your attitude management is a little bit less ineffective because you're more sporadically changing direction, but largely it still functions. If path manager doesn't run at all, attitude manager will continue to fly in the last heading that path manager gave you. So if path manager said to go up the last command and then never said anything else again, you would continue to fly straight up. At that point, you would probably sort of negotiate user control back into the system, or you might, ask path manager to like, restart itself. Is it likely for it to get stuck and never run again? Not really. Would it block anything else inside of System Manager if it took a long time to run? Also not really. Since attitude management is being handled in its own thread, that's at a fixed frequency, and that will keep the drone in the air. As long as this happens as fast as it can, you're getting the most up-to-date data to attitude manager that you could reasonably get, and it seems that it should be okay if it's there. I will, however, say, Neha will be very angry if you ask her to change the implementation of this again.
So how is it implemented?
As a finite state machine with transitions that don't need to exist. And Path Manager is a lot more complicated than Attitude Manager to re-architect, and we don't have enough time to actually
So it currently runs as its own thread,
yes.
and we don't have enough time to fix it if we wanted to switch away.
No, you could just call Path Manager execute from SM.
But we would also need to know the state of Path Manager.
I don't think so. Path Manager interface just says PM.execute.
Sorry, how many, well, like, it's gotta transition through its states to get to the output state, right? Like, presumably, System Manager would, need to, or we would want to run Path Manager in its entirety through all of its states to get its output, right?
Right. Your output will be a struct that goes to AM through SM. Oh, but you can't really see when that struct's been updated. Not easily.
The other thing that is coming to my mind again is this idea of a controller interface, where it's like the output of Path Manager goes to a controller, the actual like teleop commands go to a controller, the ground station commands, if there are any, if those exist, go to a controller.
Yep.
And that picks the thing to use. But maybe that's
Not
System Manager.
That's System Manager though.
And I think this is, I think I mentioned this to you earlier this week. And you said no something, something. I can't remember your justification as to why.
Who mentioned?
I suggested a controller, but it might have been in a slightly different context, which going through this.
I remember. You wanted something that, I think I remember. You wanted something that basically made it so that all the inputs going to Attitude Manager were always the same.
I mean, at this point, we've defined them to always be the same, right?
No, like you would do something where like you map the controller inputs to change, like you would calculate them as like GPS coordinates or something to give to Attitude Manager, and then that way Attitude Manager always runs controls in the same flight mode.
Sure.
I think that was sort of the idea.
I guess the thing that was most important in my head was that the controller class would be in charge of deciphering the various controller inputs, or the various inputs that are designed to control the aircraft, and choosing the appropriate one to feed to Attitude Manager.
I think that's valid.
I think that was what I was envisioning.
Okay.
I may have just poorly communicated.
Yeah, I think that is good, and it probably should be done, because that way you're giving Attitude Manager like a set struct of how many commands each time.
Which I think we've, again, already defined.
Yeah. I think what would be bad is if you turned your stick inputs into a heading or some fixed data type that then fed to Attitude Manager, because that takes away the safety of being able to sort of wrangle back fully teleoperated control.
Hold up, though. Attitude Manager is taking instructions which we've defined as current attitude and desired velocity, right? Like where we're going.
It takes in a desired state. And that state can be where it's like we can. So let's just talk about if we're flying autonomously. I can either be in level mode or I can be in GPS mode. Or sorry, teleoperated. I can be in GPS mode. I can be in level mode. I'm going to ignore acro for now, for a quadcopter, right? There might be times when you want to fly in level mode, and there might be times when you want to fly in GPS mode. Can we agree on that one?
Yes.
Okay. What I think would be an issue is when you sort of give this controller class the level mode and the GPS mode distinction, how does it tell attitude manager which one to do the control loop for?
So I guess in my head, the attitude manager doesn't need to know which one. The control loops are essentially the same for between, I guess, like a GPS mode and a level mode. And you're targeting a fixed velocity, for example, or I guess airspeed velocity,
Okay.
most accurately.
So now we talk about a fixed wing. How do you target a velocity?
I think it's that same thing. So like you're flying forward and your desired velocity is perhaps slightly above your angle of attack. Or it's slightly to your left. And then maybe, I don't know what the mixing is, but it does like slight rudder right or left or whatever, or something like that.
And then if I wanted to sort of take back full teleoperated manual flight of a fixed wing aircraft, would that happen inside attitude manager? Or would that be something else? Like a failsafe or like a recovery state inside state manager? Because my thought is that your state manager shouldn't care about what flight mode you want to be. It should just know if you're sort of armed, disarmed, autonomous, or teleop, or like whatever flag, and then it'll give the rest of the information to attitude manager, and attitude manager will figure out how to do what you want it to do. If you guys have opinions, you're free to share. It's not just me, Nathan, it's everyone present.
I have too little knowledge to contribute.
Okay.
Yeah. So my concern is this is getting into attitude manager needs to decipher path manager, and it needs to decipher controller inputs. When I think that's not its responsibility, right?
So in our current AM system, we put the controller signal directly in the control loop mode, right? So if we import path manager, can we put it before? So we have a previous data imported into the control loop mode, and they do a calculation and that. So we have instruction processing, right? Can we put that part as the pre-calculation from path manager to the data, to reach the data for the input for our control loop?
Here's a point. Not specific, like an extension of your point. If you're playing GPS or stabilized fixed wing flight, you have to run path manager.
Sorry, say that again.
If you're doing GPS or stabilized fixed wing flight, you need to run path manager.
Okay.
Because what it does is it takes your point now and it'll set up point very far away because it's a fixed point that can't turn in spot. And then when it gets to that point in GPS mode, let's say, it'll run circles around it as you define it. And that's path manager. Which means, I guess,
Like, I guess that's sort of the loop that my brain's stuck on as well.
yeah.
Just curious,
Mm.
this could be like not related to that, but how often is waypoints made? Doesn't it have like some kind of measure to like create a waypoint?
Yes and no. So waypoints can be created. They're created by computer vision.
Oh.
And they're sort of created whenever computer vision determines there's something that needs to be worried about. Or I think this competition season, all the waypoints are given to you already. We'll preload them, and computer vision will tell us, you know, these are the waypoints that we want you to fly, and then we'll sort of fly that sort of set of waypoints.
Although, something that's been on my mind the past few days is what if there is obstacles at a given altitude?
Oh, true.
My talk with Sahil with this is that it is the responsibility of computer vision to command you to go the right way. It's like if you're driving a car and you're driving into a wall, that's on the user giving the bad input to the car. The car did exactly, like, I set cruise control to be 100 kilometers an hour into a wall, that's on me.
Yeah.
That's not on the cruise control system, right? Like obviously cars now have like safety features and stuff, and now they'll prevent that, and we could have some safety features, but the main idea is that computer vision, the one that's giving us the waypoints, should have, you know, given us that good data. And you should have a teleoperator there to prevent your drone from, but, yeah.
So in a path manager, are we having like fancy algorithm to predict the curve, or we just have straight lines? So first waypoint, second waypoint, straight line. If there's obstacles, I just bring more waypoint in between to avoid them.
Yeah, so what Path Manager actually does, it takes in however many points it needs, like this, let's say. It'll fly, it'll create the straight line path between them. And then when it gets to this, near this point, it'll basically create a curve of a specific radius so that you're tangent on both sides. Okay? And it does that using some basic trigonometry. And so if you have a very wide turn, for example, you can get like a fairly large radius turn as long as it's tangent on these two sides. I forget how you mark tangent on a circle, but if you have a very small angle, for example, like this, then your radius will be a lot smaller because these two tangent lines are a lot sort of closer. And that's sort of how it does the path management on a very simple level. And I don't mind keeping it this way.
The only concern is we have to, the radius needs to be within 50 meters or something
So I
for
told Neha,
this competition.
do the point to point first. Once we can do like point to point, then we can worry about the turning. Like, because we can always get to the point, hover, rotate, and then we keep going. This is more of the like, we need to get this done rather than we need to do this right. Yeah. Okay.
And do we get position using GPS? How are you gonna get position? Do we
Yeah,
have-
it's from sensor fusion. Yeah.
Oh.
Okay. So, our problem, Attitude Manager is either going to receive something from PM. The way it is right now, it would either get something from PM, or it would get something from controller. Is there anything else I could receive?
I don't think so.
Okay.
What does telemetry manager do? I still don't know.
Can we finish this one first?
Sure.
And then I'll get to telemetry manager.
So the answer is no. Not important. Not telemetry manager.
Yeah, so telemetry manager is more so like communications manager, like reporting and stuff.
Sure.
So this is one kind of structure. This is struct 1, I guess, where you have like x, y, z, magnitude, and then velocity. And then on this side you have
Sorry. Velocity. You've got x, y, and z and magnitude. Those don't constitute a velocity. How do you encode velocity?
This is for auto takeoff landing, where you're having velocity targets on an infinitely large magnitude x, y, z. So you stay in the same place, but you have a very big velocity target. Or if in the future there's any reason why you, let's say, need to fly at a specific speed over a certain area.
Still doesn't make sense to me. Okay, so your z is changing when you do a takeoff,
Yes.
and your velocity therefore is just the z component of the magnitude, or the magnitude in the z component, right? It's just, so why is that represented as a separate thing? Because x, y, z magnitude is a vector.
Yes.
Velocity is a vector.
Yes.
Why do we need two different vectors, and why are they encoded differently?
Because if I'm here in space, oh my god. 2 seconds. If I'm here in space, okay, better. Let's say I'm here in space. I might want to get to this point here, right?
Okay.
Or I might want to get to this point. That's, you know, a little bit further away, right? I might want to approach both of these points at the same velocity. Let's say, like, I want to approach them very slowly to come in from a landing loop, right? I could want to approach these at the same velocity, but the bank angle that I would necessarily need to reach both of them would be significantly different.
Okay.
That's-
So you've got is velocity just speed? Okay.
Airspeed.
Okay.
Or ground speed, depending on whoever the fuck you talk to. Sorry, language.
Do we need a variable for time, or is it just calculated already in the path ratio?
Yeah.
Time?
Like, I mean, for velocity, when you weigh out the position of twin velocity, like the x and y, you see over time.
No. Okay, so when you're flying, so if this is like got a relative amount of direction, this is going to be airspeed, most likely, or ground speed, depending on. But like it's given to you from sensor fusion.
Okay.
This velocity
Okay.
target.
Is the magnitude or like what's
Magnitude. So
Yeah.
these are unit vectors. I don't know why they're unit vectors. If we have we could just make these regular numbers and not have a magnitude. But for some reason, and Gordon knows, I think we have unit vector and then a magnitude. And then we have this number that we could potentially use, or we could not use if we don't need to.
Is magnitude to calculate in vector?
Yeah. So like.
Because I was curious why magnitude was there.
Yeah. But Aiden, does this make sense to you?
Yeah, so, oh, I think so. This is the where to go, direction the direction to go, the distance to go, the speed to go.
Cool. From RC, you would get something that looks like control your throttle.
For input, for flow.
is it like quadrant? How do you say it?
Quaternion?
Quaternion? No.
No.
Okay, so from RC you would get pitch.
I don't understand quaternions, for the record. I tried to ask a professor in first year and he was like, yeah, good luck.
For what?
What a quaternion is.
I think some
Like-
people will just understand quaternions, and if you don't just understand them, good luck.
What's that?
It's a way to represent angles. I'll stop there.
Yeah, there's 4 numbers for 3-dimensional space.
Never did.
And it's not just like 1, 2, 3, or wait, it's not like the 3 axes plus a rotation. It's more complicated.
It's some kind of translation of where you are in like a Cartesian coordinate to, it's based on unit angles. Yeah, whatever. SF uses it. Don't touch SF. Pitch, roll, yaw, throttle. I'm gonna add in a little line of less important things, but flaps, flight mode. Is there anything else that I would give? Flaps, flight mode. No, I don't think so. Like most, I can see you wanting to like turn on lights or something, but that would be given to system manager and not to additive manager.
And the reason why they're vectors is because it's easy to get the direction from, because it's easy to compare directions, do operations on them. When you have variable size, it can mess up those operations. Unit vectors are just really nice to deal with. And to get the original vector out of them, you just multiply by a number instead of having to do division.
I see. Thank you so much, Sahil. I should probably check VC chat more. Just disappears after. Okay. Does anyone notice anything missing? Pitch, roll, yaw, throttle, flaps.
So we also have things like arm, disarm.
Does that, like these are like do a gift of. Yeah. Okay. Transition.
So yaw is rudder, right?
Yeah.
Yeah, it's not like it's stick inputs are like 1-to-1 for different surfaces between quad or fixed link.
Helpful.
Okay.
So elevator and what is it for?
Elevator, aileron, rudder, throttle.
Oh, elevator.
They are different control surfaces on a plane.
Yeah. Maybe don't use the black one because it's very heavy and. Can you grab the one with the red tape on the wing? The one on your left hand. Yeah. Yeah. Okay. The black one is not actually reward money, so I don't want to drop it by accident.
It isn't?
It is not.
It's got WARG motor and prop and the foam board that.
The foam board that we bought? I thought Andy bought that black foam board.
I thought Hamza bought it. Hey Hamza,
Yeah?
the black foam board,
Yeah?
that was bought by you, right?
Yeah, but it's Andy's.
It's Andy's? Okay.
Okay, yeah. I just don't want to break his foam board that he put time into. I'm okay with like us breaking motors and stuff, but okay. So pretend there's a nose on the plane, okay? And it flies forward this way. Make sense? There's no rudder on this one, but rudder would be the one that wiggles in the back. Push it one way, your plane will rotate the other way, right? Elevator controls sort of the pitch of the plane. So elevator up, and your pitch will sort of push this way because the wind will push this part down, and you'll tilt up, down, other way, right? Okay, your ailerons are these two things on the wings. They will always be moving sort of in opposite directions, and so if I wanted to bank to my left, I would bring these ones up and these ones down. The air hitting this flap, or aileron, would push this wing down. This one being down, the wind hitting this one would bring this wing up, and I would turn. And then once I'm in a banked state, I would return to neutral, and then I would sort of use the elevator to sort of keep turning with a bit of rudder. Make sense? Flaps is basically, if you have other control surfaces, you can bring them lower to basically increase the distance between, the delta difference in distance between the top and the bottom of the wing. It basically gives you more drag and a little bit more lift, and it lets you fly slower. So if you're landing or in the certain situation where you want to fly slower with more lift, you can do so. They're just a lot less efficient than just designing the wing better. But that's why they're like used on landing and takeoff, and not during regular flight. That corresponds to, on a drone, you get pitch, which is sort of left to right. Oh, no, roll, which is left to right. Pitch is just forward backwards, and then yaw, which is sort of in that plane.
And throttle?
And throttle on a drone goes up and down, and throttle on this thing goes forward and backwards. So they don't really map very
Oh,
nicely.
with the air, oh, with the plane.
Yeah.
Oh, that's why you said it doesn't really map.
Yeah.
And we try to make it sure narrow, so it works both on the drone and the plane like that.
Well, we're trying to make it as generic as we can. We like there are parts of your code that should just work when you give it something. The more decision you give to attitude manager, the less it cares. Like the more you take away from it just controlling attitude.
In my humble opinion, we need a unified input to attitude manager based on these.
I'm partial in saying this is your unified input because 90% of the time you'll be flying in this mode. Like you probably don't want to fly your plane directly teleoperated when you're flying at competition so far. Like you'll probably want it to be in stabilized mode if you had that available. So I feel like if you let this one be sort of the main thing that attitude manager always has to deal with, that makes sense. And then you give it that override for this, which is your oh shit moment. Because the control loops that you'll run for these two are different.
Okay, so we never fly quad without attitude manager.
Yep.
Like that just doesn't happen.
But you can,
Right. But we cannot, or sorry, we can fly a fixed wing without attitude manager.
yes.
And that's, I think, where your head's at, is you want to be able to take over should the aircraft be all screwy.
Yeah. That doesn't have to happen in attitude. Although, if this is the takeover of all screwy part, then you'll run some controls for a quadcopter if you're from RC, and you won't run any controls if you're from RC in fixed wing. Because any other flight mode other than full manual on a fixed wing, you would go through half manager. And so I guess you could say this is your override on the right. Can you someone put this back on the table, please? Thank you. You have to make the distinction at some point.
I guess the distinction I'm making is we never give this attitude manager at all. Like we don't even have that, oh shit, attitude manager broke code, basically.
It's also attitude manager broke, it's more so the other things not working. Like if we show up the competition and since if you like Pathfinder's not ready, we have to fly the drone.
Yeah.
And so that's when that one comes in.
Well, I guess I'm saying we, not necessarily path manager, but something else converts this into that. And so attitude manager always gets this data. It's the same consistent data for attitude manager always. And it can come from a variety of sources, path manager or RC. Does that make sense?
Yes.
How exactly, so I think it's fairly straightforward for
It's fairly straightforward.
pitch, roll, yaw, throttle, right? It's a mix of,
Yeah. So I'm just saying, as a pilot, I would prefer if the override for one of them was sort of going to be exactly how I expected to act.
If we're talking about doing an override mode, I think we are cutting out attitude manager completely.
Okay, that's fine. Then we can do what you're saying, and I'm okay with that.
Right?
Yes.
I don't think we can fly.
Oh,
Okay, so how does path manager provide heading? I'm sort of realizing it's like,
Heading such as.
like we want to rotate. Like the direction that the aircraft comes into the waypoint.
Okay. So the idea is that path manager never gives you a point that's too, so this is getting into a little bit more specifics, but you generate the path. You're here. Path manager generates a look ahead, and it feeds that to AM. And you adjust this look ahead so that AM is never going to get a thing where it's like, go this way, unless you're in a quadcopter mode.
If we're in a quadcopter mode,
Oh, shit.
and we get that, how do we say which way is forward? Like we want to have the nose facing which direction? Because we'll need to have a direction for the transition mode, or the transition states. Like I could see us taking off, and then I guess we just like fly forward and then
That's-
do a Yui,
Okay.
or we
Yui?
just spin and then fly, right?
Okay, so okay, you make this point. We had a heading in the old pan to AM struct from 2022. That was the desired heading at the end of, sort of like at that point.
Right.
We can add in a heading. I don't necessarily know if it has to be at that point or if it can be like, no, it should be at that point. It should be the desired heading at that point. And at that point we'll keep moving, but you will always recompute for that heading. Well played.
Okay. So heading at the waypoint, I would imagine in a quad orientation, then.
It could be in fixed mode too.
So I'm thinking just quad right now. Okay. You're here and you're facing this way. We want to be here facing this way.
Yeah.
Do we turn then go, or do we turn and go at the same time? And if so, how do we figure out how fast to turn? Is that attitude manager's responsibility or path? I think that path. Or sorry, the input.
If they wanted you to turn and then move, they would give you no direction and then they would make you turn and then they would make you move. and then I think when you do the AM calculation for where you want to be, you can come up with the fancy math for it now. Realistically, you'll probably just do a controller for how far off you're on yaw. And that controller will mix in with the rest of your distance controllers and it'll get you there.
Okay. So we have heading now.
Yes. Gordon's gonna kill me. These are all
Pitch matches, maps to X, roll maps to Y, yaw maps to heading, throttle maps to Z.
roll, yaw.
So that's an easy mapping for, or easy
Yeah.
mapping for,
Oh, that's the same color. My bad.
let me see, or like for quad
Yeah.
for fixed wing. We have rudder, aileron, elevator, rudder.
You'll need to do a little bit of math on that to make it not when you move the stick, but that's the general number.
And so the format of these is the same going into Attitude Manager every time. When Path Manager is in fixed wing mode and it gives X, Y, Z, magnitude, heading, and velocity. That's actually just rudder, aileron, elevator, rudder, magnitude, velocity.
Yes. Well,
Well, they need to be the same, is what I'm getting at, going into Attitude Manager. If it's all the same interface.
assuming this is not the panic mode, then yes, because you like. Let me get some water. My throat hurts. I'll be right back. Sorry, Ian. But coordinated turns. I'll leave that for you to think about while I get some water.
You want me to think about coordinated turns. I don't know why.
Argument going on.
Sorry?
No, nothing.
Coordinated path manager should be coordinated. I believe coordinated turns is the idea of you've got like point here, point here, point here. Your aircraft is here.
So it can be magnitude times the angle, right? The polar form. If that's the case, can we explain it by the last two one? So we have the heading, we have the magnitude of it, so it's just polar form of it.
Sorry, heading being the direction the aircraft is traveling, not, the direction the aircraft is facing, not the direction the aircraft is traveling.
But we can do the X, Y, Z calculation to get the angle, right?
Not necessarily.
Oh.
We might want to be facing a different way when we get to the way. So, for example, the waypoint could be here. We could be here, right? And we want to actually be, when we get here, facing that direction. So like, in a fixed wing, that means we fly like this. In a quad, it means we fly like that, but we also rotate at the same time.
But can we fly to that point and then rotate? If we snap into, break into two pieces, that will rotate.
We could, but I think the idea here is, given this, turn coordination should be attitude manager. Why? So,
Kid, Sahil's not even like in the voice call. Like I can't see him here.
Like he just knows.
He just knows.
What? Is that you?
Did, so,
He might be on the stream. That might make sense.
I'm a little bit scared of this.
so, I have my understanding correct, coordinated turns, you're like going through them like that as opposed to going like here, and then like doing that, right?
Coordinated turns operates on a much smaller scale, where it's just sort of, so you have, I'm erasing this one. Okay. So you have two types of turns. So like if I'm in a plane, how do I draw a plane? Can I do like a box with two?
I've just been doing like an arrow,
Okay.
like that.
So this is my plane, right? Don't roast me. One way to turn is you sort of just do your rudder input, and then you turn like this in one plane, right? The other way to turn is if you have your plane sort of like this, and your rudder here, then you can turn sort of in this direction going forward. Do you understand what I mean?
Yeah.
Because the force vector is this way. And when you're turning, you basically want the acceleration vector, or like the force vector, to go straight up. Because that way you're not slipping this way, and you're not sort of sliding in this direction like that, badly, right? Did you say you were scared of the hill? Did you? Aeon, come here, Aeon, come here. Come say hi to the hill. Come here.
Why would you want to name and shame?
Come here.
No,
Come here.
job.
Come here. Look. Okay. Make sure you can see yourself. Okay.
Who are you bullying right now?
Aeon, say hi to the hill. I'm sorry.
Dude.
Is this like an apology video? Like, cause like you
This
can
apology video is Ruben crying in the thumbnail.
I'm sorry, Sahil. I didn't mean that.
Okay. Now Sahil has to apologize too.
I think you need to
No.
apologize, Anthony.
How are you scared of him? Why would you be scared of him?
Don't be scared of Sahil,
Like,
guys.
This guy's like
Right.
solving our problems. The moment that we have a problem, he just pulls up out of nowhere. Out then he just fucking solves the problem and leaves.
He's a ghost, I swear. Okay.
Bro, I didn't mean. No, I didn't like.
That she agrees 100%, bro.
I'm sorry, you good? We're okay?
No, it was just funny.
No
that you
emotional
heard that.
damage?
Out of everything.
Are you gonna go home and like
Just
Cry.
like think about
Be
it.
sad?
Just stress.
After
She's gonna
picture-
quit
Oh,
because
no.
of you.
Okay,
No,
that's
it's
not
okay. That
okay.
was fun. Apology video. I guess team, huh?
He's typing. He's typing. Okay, so yeah. So coordinated turns does this on a very small scale.
Yeah.
Holy shit, Annie's the one to be scared of. That's what Sahil said.
Never forget the apology video you made me do.
Wait, this is recorded. Okay, so we do have the apology video. Okay, sick, bro.
Okay, so coordinated turns. And so like when I say if you're from RC to here, it maps, but not like it's basically like a GPS flight mode from RC if you're doing this, right? Which is okay if Attitude Manager works, I'm okay with this. No issues. I don't mind doing the mapping, and I don't think anybody would mind doing the mapping. It's logical. It makes sense. You give AM this struct. Neha, are you online right now? I heard you earlier.
She's in the voice chat, I think. Yeah, she's in the voice chat.
Can you hear me?
Yeah, we can hear you.
Oh, sweet.
We forgot heading for Path Manager to AM instruct. Like the
Okay.
way we want the drone to be pointed. Anyways, sorry. My brain just processed the trigger.
While you're here, also, is there a reason we call velocity instead of speed?
No reason. We can call it speed.
We're gonna change it to speed.
Yeah, because it confused the hell out of me. Because it's like vector of to the waypoint, and then vector of speed we're traveling and direction we're traveling, which didn't make sense in my head.
No, we have velocity targets and
I think it's called heading magnitude, but we can change heading magnitude to speed.
No. Don't change magnitude. Rename velocity to speed.
Sorry, rename what to speed?
Okay, so the things we want. I will see if I can actually share my screen.
Velocity to speed is what he said.
So velocity throttle to speed.
Oh, maybe this work. Okay, so you have your x, y, z as a unit, and then you have the magnitude for that unit, and then you have your heading, and then you have your speed. Did my Discord crash?
No.
Okay.
No, she just turned off the mic.
Okay. That's okay. Alright. So also, Neha, while you're here, does
Yes.
Path Manager have like time constraints on computational tasks?
What do you mean by that? Like, what would you like to do?
Does it need to run at a fixed frequency? Is my question.
At a fixed frequency? No, not that I know of.
Cool.
Or, yeah.
Yeah, we're just trying to figure out like what's running as its own thread with strict timing requirements, and what can be run with less strict timing requirements. Not necessarily even need to have its own thread.
Interesting.
But we haven't figured out what that is yet. We're so far.
Can you make an argument for why Path Manager would or would not want to be a thread?
I think it would be better as its separate thread, but I don't know. What was your conversation on that?
So basically, threads, having a thread, you're using slightly more resources, and it's more complicated to do communication between threads than it is to communicate within the same thread. And so, like, there's a very strong argument for sensor fusion to be its own thread because it needs to run at a fixed frequency. And there's also a very strong argument for attitude manager to run it in its own thread because it as well needs to run at a fixed frequency. It's less important from what we can tell that path manager runs at a fixed frequency, and it could perhaps just run under big boy head honcho main ZP thread. State the
I want
sort
to see that at the
state
top of the file, by
manager.
the way. When we make that file.
Yeah.
Just run it to BBHHMZPT.
.cpp. So yeah, what we're trying to figure out, Path Manager is in its own thread right now. We're just wondering if we could move it to another thread and what the implications of that would be, or if we moved it to not be in its thread, what the implications of that would be. I don't know if you have any thoughts.
I don't think there's any terrible implications about if we move it to another thread. Sorry, I'm just trying to think about it in my mind right now.
Yeah, no, take your time. Shout when you have a thought, an idea.
Yeah, I don't think it's a problem.
Cool.
Okay.
Doesn't mean it's going to not be its own thread. Doesn't mean that, right?
Yeah.
Doesn't mean we're going to just disagree, right?
Yeah, it doesn't mean it won't be a thread, doesn't mean it will be a thread. We'll figure that out later.
Yeah. Sorry, what were you saying about velocity again?
Velocity is a very confusing word to use because it technically has direction instead of speed, which is just a magnitude.
Yeah, so what would you like changed to speed?
So right now in the struct from Path Manager to Attitude Manager, we have dist x, dist y, dist z, I think magnitude, and then we have velocity, right?
Yeah,
The
that's
very-
Gordon's velocity throttle targets.
So the very last velocity, we'll just change it to be speed because it's it's essentially just the speed, right?
Right.
And so if we name it speed, we'll get less confused in the future because first year physics has impacted too many people's lives.
Yeah, okay.
I totally didn't even realize until you guys started freaking out about it. I was like so past it. Okay. Cool. So this has been cleaned up and figured out.
Well, we're giving the same consistent set of data to Attitude Manager. There will be a controller of some variety that maps this data into that struct and passes it on.
Yeah, I don't
My-
mind putting this as
Yeah. My concern or thought is in fixed wing configuration.
Yeah.
We say we want to pitch up.
Yes.
Well, Attitude Manager can figure out, let's just go up. But as a pilot, say you want to perform a coordinated turn.
Mm-hmm.
What do the stick inputs look like for that? Your throttle is at some set point, right? Your throttle's up. And then you're yawing.
Okay, so you'll throttle up a bit, you'll roll, you first roll into where you want to be, and then you sort of bring yaw back to center, and then you mix in your rudder and elevator as you need, and then like a bit of roll as you need.
Yeah. I guess I'm just concerned about the translation from RC to Attitude Manager.
Right. So that's why I said earlier that as long as the panic mode is not this way, it's okay. Because if you're in a panic mode, you want those inputs to translate directly. Like that's what you're comfortable with, right? But in this case, you would fly it where your stick inputs are more like flying in GPS mode or level mode, where they don't actually translate directly to control surface inputs. They translate to where you want it to go. And as a pilot, you can probably manage, like, I want my drone to go a little bit left or a little bit up or a little bit down, and fly that way.
What if Attitude Manager had its own, like it had like another control mode
Mhm.
that is panic mode, and we use those, like some sort of union of this input struct for the actual stick inputs.
How do you tell it's in panic mode?
That is another flight mode. It's like a totally different control algorithm.
Okay. Okay. You need to tell Attitude Manager. You need to give it that information. Oh, I mean, so
This.
in our struct, we then need to add in something that tells you what it is.
Yes. That, or
Yes.
state manager says that at some other time.
I don't know if it has slots. I feel like he would. Does not. I'm lost.
I think it makes sense for it to be all at once.
I think it makes sense for Attitude Manager to choose which controller it wants, because it's back to this thing.
Yeah.
So, struct to AM. Okay. Waypoint tape. Oh my god, you know what I can do? That's so cool. Why?
waypoint type going to attitude manager?
Oh.
That seems like a path manager thing, right?
I forget the reason for it, but it's been requested and it's basically
So waypoint
Oh.
types include landing.
landing, takeoff, hover, cruise.
I'm not sure I understand why attitude manager needs to know those. Path manager, absolutely.
Because your speeds, you need to understand how to interpret this. As in, is it a minimum, a maximum, a target, etc. for takeoff landing? Which well, I guess we could take it out. I really need Gordon to be here.
Gordon. Hey, Gordon. Wait, so in conclusion, do we need time requirements? Is there time requirements for path manager?
No.
No?
Not that we're aware of.
Wait, no,
What
don't switch
about
the color coding.
for
Do not
data
touch
management?
color
Data management, like all the measurement.
Why'd you put a black semicolon?
SM no, because it's uncertain. SM
I'm just gonna do
has
everything in black.
PM
You can
not
erase
sure,
it later.
PM no.
And
No.
so AM and SM are the only ones with time requirements?
Oh, I guess
Currently, yes, because we only have 4.
Oh.
SM is the controller itself. Wait, I don't think so.
That makes sense. Thank you.
This is too small. Well, I don't think, I'm not convinced that it's a struct that we just pass in, right?
No?
I'm not a huge fan of the idea of just like passing a bunch of structs around.
Okay. I will
As
rename it
opposed
as-
to like a whole bunch, like passing function arguments or whatever. And then you can
rename
have
it
like,
DS then?
but whatever, that's an implementation detail, it doesn't
No.
really matter right now, sorry?
Oh, I screwed up. Okay. Okay. For these ones, do we keep them as XYZ or Control Yaw or what? Don't sit on that.
No, just sit on that.
Okay.
It's XYZ.
Okay.
Did you see that he answered?
No. Can you read out loud?
Where'd it go? What the hell? What channel did you send it in?
Yes.
He said, TLDR, you need either velocity or magnitude and direction. Direction is a unit vector in XYZ space. If you want to use velocity controls for smoother flight, then you tell the drone the speed to go in that direction. If you want a waypoint to consider banking and turns for fixed wing, then you look at your current heading to and use the magnitude and direction to set a waypoint to fly to.
Okay, so we don't need it, is what I'm getting. Because AM's turning doesn't care about that waypoint type, it's just flying to.
Are you talking about the waypoint type
Yes.
that PM sends to AM?
Yeah.
Yes.
That was more so to help AM figure out if it's like if it's orbit, if it's path follow. So then, since if we orbit a waypoint, it's different if we're a quadcopter or a fixed wing.
So we've decided that orbiting is a PM issue because PM has to be aware of the plane configuration anyways.
Okay, so
Don't kill me.
okay.
Sorry?
I agree.
Okay. Don't kill me. We do need to tell it though something that relates to the instructions.
So, actually, I think, sort of going back to that, like, orbiting or whatever, maybe the waypoint is here from path manager's perspective, and we're here, and we want to orbit. Path manager maybe is like saying, next point is here perpetually as we go around the circle. It's just like, next point's here, next point is here. That's what path manager passes to attitude manager. Sorry, what was your next thought?
We need something to describe. Like flight mode select or something, because like you're basically loading these same things up with many potential uses.
Yeah.
How do you or are you just loading with flight mode?
Yeah, and then mode. What do you mean? It's a type. Like an enum type.
Yeah, it's an enum, it's not a base type. Okay.
Mode.
Okay, we also need magnitude. Also be in 60. And magnitude, and I think heading and speed.
So we have three type of flight mode: quad, fixed, quad to fixed,
And I guess fix the quad.
and taxi.
No. No taxi. I mean, if we're doing it like this, do we have a landing mode and a takeoff mode?
Yeah. We were going to.
Okay, so that's what, 6 now?
There's like 9 or something total.
Quad, fixed.
Fixed. Transition, takeoff, landing, 5.
And transition,
No, I include transition.
What are you guys naming?
the different flight modes.
Quad, fixed, transition, takeoff, landing,
For AM?
flight mode.
Oh. Oh, I see.
Because remember, AM does the mixing between, yeah. I think this is actually a list of either, if it's a length 1 list, then it's just that mode. If it's a length 2 list, it's a transition between them. And we need to somehow coordinate between one to the other, right?
Give me 2 seconds.
Because we already said that attitude manager was responsible for the transition between states.
The transition between states should
Modes.
happen automatically. PM shouldn't be telling you to transition between them.
Yes, I agree.
Okay.
But this is the data that goes to attitude manager.
Right?
Some of that will come from path manager or the controller, but some of it's also coming from state manager. Right?
Right. Can you write down what you were thinking? And I'll write mine down. Do we need this anymore?
Can I just take a pic before you do
Yeah,
it?
I'll move this over. And block our exit in case there's a fire. And I'll bring my stuff too. Using color palette we used. This blue.
Different proposal, okay. Do you, I have my answer now.
I think I'm missing some stuff, but I think it depends on there.
Oh, yeah, you can erase it. I posted it on the screenshot.
Okay.
You don't pass these in. Just attitude manager holds on to a flight mode. And it keeps that until it's told to transition to a new flight mode by state manager.
Okay. I don't mind that. I think the issue of what are your flight modes still exists. Okay, so I had like takeoff and landing, cruise mode, and teleoff. That's a fixed mode. And so, in my mind, takeoff and landing lets you force a quad only mode or like force a specific mode or control algorithm. Cruise is just letting attitude manager decide how to mix it the way it wants, and then you can force a teleop mode if you like take it for whatever reason. I'll move this out of the way so you guys can leave.
Do you need anything? Do you need anything to like helping clean up or something?
No, it's okay, don't worry about it.
Okay.
What time is it?
It's like almost 10, like 9:53.
Okay, yeah.
When should we call it wraps? Today?
What is QQC?
What?
It's called all call.
We could technically take off in a fixed configuration or land in a fixed configuration. Just
But what you're getting is basically a vector straight up.
is the, flight mode any different though? Like, is the actual AM mixing any different? And I don't-
Realistically, you only need to go between teleop and autonomous, because if I'm at 0 velocity and attitude manager is mixing it on its own, it will take off in a quadcopter configuration because it's not fast enough to transition to the fixed route, right?
So like,
Oh. Yeah, because if you go back to this, you just need something to differentiate between these 3 flight modes, or like input configurations, and then you're good, in my mind. Which would be like 1, 2, and 3. And then you have this one that you could use theoretically if you wanted to force a particular action.
well, I think does so what's cruise mode?
Just autonomous flight. It doesn't matter
What-
the airplane
okay.
or whatever, just autonomous flight. So I was like,
I think the airframe is important. Cause like, I'm also thinking we've got quad, we've got fixed, we've got X, we've got octo, we've got,
right.
tilt rotor.
Are they just different, like,
I
drone?
think that's what you talked about when you talked about controls.
Yes.
And so that's why I'm like shying away from that one because it seems like it should go here. And then this one does this, but
So controls, controls holds on to the aircraft configuration.
yes.
Can we write that down?
Controls, fixed frequency, holds onto aircraft configuration.
Okay. It may need to run multiple, or controls, and may need to run multiple different controls algorithms at once
Yeah.
if it's doing a transition. So what we are talking about right now is instructions processing.
Yes.
And our concern is what does the input mean? In my head, it always means the same thing.
Because you're doing that processing outside of AM. So then do we need AM to need half-life modes?
Yes, because which control, sorry. What is a flight mode? If the flight mode is the aircraft configuration that the controls runs, then yes. If flight mode is manual versus path manager, then no.
Okay, so I don't think anything outside of AM should get to decide what the aircraft configuration or no.
Something does, because it needs to transition between the,
I'm saying AM decides when to transition. If I'm driving an automatic car, it's going to choose when to change gears.
okay.
Similarly, like if I'm driving a hybrid, it'll choose when to use gas or electric. And I think that makes sense because that's what the system's designed to do, is just control the speed of the car. Like the powertrain does that decision, right? What were you thinking?
I was thinking attitude manager is running in whatever configuration it needs to run in. And then, sorry, whatever configuration it has been told to run in.
Mhm.
Say, for example, it's taken off and it's been told to fly in a quad configuration.
Yeah.
Does all the controls and output mixing for a quad. Then state manager goes, time to fly fixed in mode.
Right.
It handles the transition between them. And then we fly, then it flies based on a fixed wing. output mode. You're suggesting, from what I'm gathering, we just give it a target, and if, for example, the velocity is above a threshold, if the distance, no, that doesn't work.
If the current airspeed is greater than certain thresholds, it will choose the control scheme that it thinks is better suited to the flying. This way is nicer in one aspect, which is you don't need to necessarily care about all of the flight modes in State Manager. But nobody else can really enforce a flight mode this way, which is bad.
Well, it's that sort of like flick a switch and transition on a controller. We're just taking that away from the pilot. Say we're flying with the pilot input, it'll be like, when we take off, and then you pin it on the, I guess the roll. You pin the roll, and then instead of tilting forward, it goes and like flies forward. And then you want to go to the right, and then it does a bank, which is great. So then you're like full forward and full to the right, and it's like doing a turn. But then you pull back and move forward, and the aircraft was banking,
And now just
and
going
now
right.
it shuts off the forward throttle, like stops and just flies as a quad to the right. That would be so cool, and it would be wild.
It would also be terrible to fly,
Yeah.
which is why there was like the cruise and the teleop. And the teleop is the one where you get like the fine degree control in your like this thing. But
It would be terrible to fly.
if I'm expecting, like if I'm in a quadcopter configuration and I'm sort of, if I want to go this way to dodge a tree, but all of a sudden I go this way and I like a bank, and then I like, you know what I mean? It's like you would probably realize and you'd probably fix it, it would just be weird.
Well, so I'm thinking like, you're flying towards a tree. You decide you want to turn a direction to avoid the tree.
No, actually, I think it'd be okay.
Either way, the aircraft is going to go.
It's going to go
the
in
way
that,
you tell it.
because it's going to be an XYZ, it's going to go that way.
Yeah.
And so it should be okay, because it'll get to that point. As long as you sort of don't get super close to a tree, it'll be okay. Yeah.
feel like so it would be perhaps bad in the fact that you'd like have to you'd have to pin the stick to stay in fixed configuration. Right? So like you want to fly forward and you want to fly fast in the fixed wing configuration. You have to like be pinning the stick forward.
You can change. You can make it so that if you're traveling at a certain speed, you'll like you make it very long.
You make it what?
You make it. I was thinking like if you're here and you're going this way, it'll look like you're basically going to change where this point is. That's how fixed wing stabilized flight works.
Sorry, you are the arrow?
I am the arrow. I'm this very arrow. That's how fixed wing. So like I guess like you would have to keep the stick in to keep going this way. In my mind, oh crap, no, but you're right. Like, throttle does two different things.
Well, I don't think we call it throttle at this point. We call it altitude. It's forward, backwards, left, right, up, down.
It's gonna stress the fuck out. Do we need a little
okay.
break?
See, this is like you're like in this instance, you're saying it's altitude, right? But if I've been flying fixed wings for a long time, I'm expecting the left stick to be how far you go forward, and the right stick to control altitude. And like that's where you might not want it to do it automatically because the pilot might be expecting one control scheme and it might not. So like, you know what I mean?
Not exactly what you mean. Problem is, like, you then go to quad, it's one way. You go to fixed wing. The same stick inputs have different meanings.
I think mentally that transition is okay. Especially if it's like on a GPS mode, I think that transition's okay. I think what's more confusing is if you like the way you fly a quad and the way you fly fixed wing is fairly different. Mixing them in your heads in this GPS weirdness is really weird to me.
Also, there's going to be a point where you're like flying forward as a quad, and then you want to, you're going to go fast enough that you want to switch into fixed.
Yeah.
So then you have to like pitch up.
Not necessarily. Because
Like that.
your quad will just stay level, and then you'll run the push, and then
Oh, but say you're already flying forwards,
yeah.
and then you decide you want to fly forwards faster.
Mm.
You either slow down, like level out, slow down, and then speed up, or you speed up, go down, and come up. Right? Because your push motor will pull you down, since your nose is down.
You know what would be cool though? If you could choose which one you're in on a switch, and then you can do another one to say like enable transition, like allow transitions, and then it'll transition, and then it'll allow the transition one way, but then to allow the transition the other way, you need to like flip the switches to allow it the other way. So like if I had
Oh, so you're saying like, actually it's like a two-way switch, for example. You're in quad, you flick it to fixed. You stay in quad until you've successfully transitioned out of quad and into fixed.
yes, so I would make it so that you need it like I would make it so that you have like one switch here, which is like quad or fixed, and then this one would be like allow, I think, if you're here to be quad to fixed, and this one will be fixed to quad.
Yeah.
And then so that way, I can go one way, but I can't go the other way until I've explicitly said I'm in this mode now, and I'm going to allow this transition. And that's probably enough time to let you like properly figure it out. It's honestly just, or I guess you could do a 3 position, which is like current to fixed to quad.
I think that's probably.
I'm not a fan of 3 position switches though.
Actually.
It's really easy to go past on that, and it's confusing.
I'm not a fan of that either.
Okay.
And again, if we do that, we're giving it back to a, to say what state to be in, or what mode, right? Or sorry, we're taking that away from it, rather.
I mean, we could do fixed quad, and then this one could be on one.
I think again, if we do this, we're taking it away from AM. It's the choice of what mode you're in.
Okay, thank you for today.
See you guys.
Thank you. See you.
Right, so I'll probably message you, Annie, or whoever, and just try to get more like where I can start to like actually understand the architecture, like what the hell each class does, like the tele manager, AM, SM. Is the SM the system manager like new?
Yes.
Okay, I
Let's
know.
just check the confluence. I think we have some.
Yeah, do you guys
documents
have
for it.
like any documentation on like a good starting point to start like understanding the architecture and what
So like,
each does what?
this is the designing the architecture
Yeah.
discussion. So like no.
If you understand, if you want to find current stuff, all of like the Zero Pilot 1.0 stuff is really good to read through.
Okay, but it still shares some similarities, like the definitions of the AM, like how vastly different would it be?
AM is gonna be very
Very
yeah,
different.
don't read on AM stuff. You'll just get more confused.
Okay, so where can I catch up to like actual recent like AM discussion talks, like?
This is the most recent.
this is it.
This is it.
Oh shit. Okay.
Yeah. There will be a huge long recording that you can go through later. If you ever, it's gonna be like 4 hours long.
Yeah, I don't know how I'm gonna be able to like listen through that.
But I think I might write some documentation tomorrow. I might
Okay.
not. I have midterms next week.
Yeah,
I
yeah.
don't think you have to work on that then. I think you need to focus on the midterm.
But I will probably write enough so that everybody who works on this knows how it'll function.
Okay.
Or I'll take a picture of this and then I'll say like, me if you're confused.
Okay, gotcha. Thank you.
Alright then, maybe like, I don't know if you wanna like sit down and just like review to like the most important parts of the AM, just like compress it, like just dump me with a whole bunch of info for
The
AM.
most important parts that we know is this.
Okay, so the
It will get some instructions, which is sort of what we're trying to figure out right now. It will get instructions, we don't know what they are. It will then run a controls algorithm that is appropriate for the aircraft's configuration.
define like
So-
what exactly control and what kind of configuration.
So controls would be like running PIDs for pitch, roll, yaw, and throttle in a quad,
Okay.
right?
Mhm.
Saying like we want to go this way, and that's that.
Okay.
So it would be running those controls algorithms
Mhm.
to control the attitude of the aircraft.
Alright, so
And then output mix would be taking that data, doing whatever mixing needs to be done,
And then output it.
and then sending the commands to the motors to spin
Okay.
at whatever speeds. That is the role of attitude manager at this point.
mhm.
Okay.
And sorry, I was gonna say this is a closed like feedback loop where you're constantly taking in like info from the motors and whatever controls and repeatedly like using the previous measured data and you're outputting again and doing the controls thing.
It's basically a fancy closed loop controller. You can
Okay.
think of it that way.
Alright, so that's the attitude manager AM. That's just what pretty much controls the drone, the plane, or whatever, the aircraft. You know, fetching your instructions, whatever you guys are working on right now. Does its controls for controlling the actual drone itself, motors and whatnot, PID stuff, and then outputs into a certain format, right? That's the right. Okay. TM, what does that do? That's a
I'm
telemetry.
defined right now.
Defining. Okay, so what are some of the things that we have, like, in someone an idea of what each part does exactly, what its main sole purpose?
Manage communications.
Management communications.
So
Okay.
like with the ground,
Oh.
with the Jetson, maybe.
So
probably.
basically, anything that's not on Zero Pilot, communicate with that.
So like all of the external interfaces will talk through telemetry manager.
Okay.
And
Alright.
it will, telemetry manager will send telemetry data back to the ground, for example.
Mm-hmm.
It will receive controller input through telemetry manager,
Okay.
that sort of thing.
Maybe.
Maybe.
It might be a system.
Okay.
We'll see.
Yeah.
And then PM is just a path planner management
Yeah.
thing that you know sets the waypoints, yeah, exactly, and calculates where we need to go. And then when it outputs data to AM, okay, that makes perfect sense. And then SM, the system management that you guys newly defined, that's now what's going to be like. I guess that's what's everything that goes to Zero Pilot has to go through system manager first, right?
Yeah.
Like you can't go to directly AM, TM, or whatever, any of these without going SM first.
Isn't that already, isn't it going to AM first?
AM is sort of like the last step in the pipeline.
Because AM is like what's controlling, like before you want to
Oh,
do
yeah, 'cause
anything.
you gotta output it to,
Yeah, so we haven't defined if all of communication is gonna go directly between the various managers and state manager, what do we call it, system manager. We haven't defined that, if like system manager acts as like a router between all of these,
Mm-hmm.
or if they talk with each other, and system manager tells them, or like gives them high level instruction. We've not decided on that yet,
Okay.
but, I don't know, I have some thoughts.
Okay. And what is this the quad and fixed thing? What are you guys like? What is going on with that? So quad, fixed, hex, octo. That's all different types of aircrafts, correct?
Yeah,
Okay.
so, trying to decide, where the division of responsibility is between attitude manager and system manager. What knows what about the actual aircraft's design?
Mm-hmm. Okay.
Attitude manager definitely needs to know. It needs to know if we can fly in a quad state, or if we're flying in a quad state, if we're flying in a fixed state, or if we're flying like something else, maybe a helicopter state.
Mm-hmm.
So it needs to know that. The question is, how do we send our commands to attitude manager in a way that we like, that is intuitive to the pilot,
Mm-hmm.
while also being interoperable with path manager and the various flight configurations, while
Mhm.
ideally not really caring about what type of configuration the aircraft is in. I think that's sort of what we're stuck on right now.
Yeah, I think the biggest one is that there's a pilot that needs to operate the system,
Yeah.
which, you know, you can't, I don't know, you can eliminate, I guess.
Okay, so you said something about the being inoperable to PM. What do you mean exactly inoperable?
Interoperable.
Interoperable. It can operate with, like, the same data that comes out of Path Manager is the same data that comes from the pilot, basically.
So you're essentially saying we have a bunch of different drone types, like whatever the quad and fixed, and the controls that we like the inputs, the variables that we pass to PM and AM, we want to generalize it that it fits all, like quad, fixed, and so on. Correct? I'm having the right idea.
I've come to a realization. You can let state manager choose this thing, and it just doesn't math in a different way.
And just does what?
Math in a different way. Like it just maps your controller in a different way to AM. And so then your pilot can choose which map they necessarily would want to use. And then AM wouldn't care because it would just, do you know what I mean?
Yeah. So like, what is throttle on that? It would need to be like a flick of a switch.
You would need to flip the switch to switch the map. But if you were more comfortable flying in one configuration than the other, you could theoretically fly the entire time in that in that map.
You could even do that on the controller.
Yes. I'm not a fan of playing with controllers. It's too easy to screw up one thing and
Yeah.
Crash.
controllers are really powerful. You can do a lot in them, but you need to know what you're doing in them.
And right now, the controller versus what exactly? So the RC is the controller itself, right?
Yeah.
Versus what, like autopilot, autonomous, like. What's the other
You
thing?
basically when you fly I'll grab a controller.
It was the one where you're just talking about the controller has the yaw, pitch, roll, input commands, correct?
Yeah, so like if I draw my controller here, he draws his, and I'll draw mine for fixed wing, he'll draw his for quadcopter. My stick moves in 4 directions, on the left and the right, correct? For fixed wing, this channel is going to be throttle, which is forward flight. This channel is going to be rudder, which is sort of like heading. This channel is going to be aileron, which is like roll, and this one's elevator, kind of like altitude. And roll, I guess, I'll actually just name them the same as this. So elevator is going to be pitch, and rudder is going to be yaw. So most of it is fairly similar, except that on the 2 flight modes, pitch and throttle are flipped. So in this case, to go up in a fixed wing, I would move my right stick. In a quadcopter, to move up, I would move my left stick. And if you're piloting a drone, you want to know what your stick input is going to translate to on the drone. You don't necessarily see what might be above you or below you or around you. And so coming up with a way to make it so that you can go between these two for a pilot intuitively or semi-intuitively, easily, is something we're trying to consider and design for right now.
Wait, what switches between the pitch and the roll in a quad and fix? Sorry.
Like how your input on a controller gets mapped to your request for movement in attitude manager.
I see.
So like, the thing to notice here is its pitch roll are on the same axes, right? Pitch, roll, or throttle, yaw.
Yeah.
Like they're the same mappings. It's just on the aircraft, you achieve those in different ways. Throttle is your forward velocity, basically. Throttle on a drone is up and down, right? And so I guess, what is it? Elevator.
Yeah.
Is in quad is forwards backwards.
It's
On-
pitch roll yaw most of the time.
On a quad or on a fixed, it's up and gain altitude.
Yeah. And so if I'm expecting to be flying in some mode right pitch and I gain altitude, and I pitch and I don't gain altitude, instead I go forward more, I might go into a wall instead of going over a wall. So we're just trying to work out right now how we can do this mapping without having AM be super, like while leaving AM basically doing AM things and not having it worry about other stuff. I like that idea. That SM chooses the switch. I think it's the least bad.
And so the data stays the same.
You had yeah, I'm like sorry too. Alright, yeah.
See ya.
I'm gonna head out as well. Alright, see you guys.
Good night. Okay. So the data stays the same, right?
Yeah.
But, attitude manager. So attitude manager won't differentiate, the only thing that changes will be the pilot input is mapped to what is expected.
Yeah, which is what state manager is supposed to be doing anyways with like arming and disarming.
And so like on the aircraft, you'll be going forward with the quad and stopping and flick the switch, and you'll throttle up to go forward the other way. Or with the other stick, you'll just do that.
Yeah, more realistically what I see happening is you'll go into a hover state, you'll put your sticks to neutral, and then because like because you're giving it an XYZ position, you're not giving it anywhere to go to, it'll just stay where it is. You can sort of bring your sticks to neutral, flip that switch, and then keep flying. I think that's like it's basically giving it this option. Because you only want to fly one way or the other in like very limited situations, right? Especially like, there's no actual world where you're switching between the two a significant amount. And so I think going up, hovering, flip the switch, mental reset, check everything, and then go is I think in my opinion okay for me. That's like from a pilot perspective.
So, do we actually need a pilot, or we don't? So if we're kind of like this, so fixed wing to quad, quad to fixed, if those can be made by us, do we actually need a pilot then?
Not really. Like you could fly the entire competition fully autonomously if you wanted to. There are if you go to competition, if you've ever used autopilot, you click on a map and the plane flies.
Well, we can't use autopilot during the competition.
And our software is supposed to be the same thing where you can basically say, go to these waypoints, do the thing, and then it'll just do it on its own, right? You just always have to have a pilot there in case to take over for whatever reason. And if you want to build a system so that if the pilot needs to take over, they can, do so easily. Because there's a very high probability that, we get to competition and not all of our software works perfectly. So maybe auto takeoff landing works perfectly, but flying autonomously doesn't work perfectly, or vice versa, right? And so you need a pilot to take over some part of that. And so that's when this sort of comes in, and you want to make it so that it's the most crash-proof as possible.
Got it. Makes sense.
Almost there, even. Almost there.
So Aiden, do you figure out what will be in the system or system management?
I think system manager comes last, unfortunately. We need to figure out AM instructions, processing. And I'm wondering if we can do multiple, no, attitude manager needs to do it. I was gonna say like multiple different types of instructions, and then like multiple different types of instructions, and then they get interpreted differently, right? Like that was that, and
I will move this so that they can see the other thing. It looks okay. We can AI upscale it later. Okay, so a little bit of the right and the left is going to be cut off, but that's okay. We live with these. Just check this first.
I need to talk to both of you about something related to ops. So, when do you guys think, are you guys gonna be done like in half an hour?
Okay, how long is your office thing?
Like it'll take a bit
Can you describe briefly what it is?
for the funding stuff.
Okay. Funding stuff for like this term?
Yeah.
The nature of the funding stuff being
MEF and we. It's not like insane high priority, so we can talk about it in the morning over Discord if that's easier.
yeah, I think I would prefer, I like this thing where if there's discussion that's been had, we sort of prepare the options first, and then we can just conclude.
Oh, it's not that kind of.
It's not that kind of discussion?
I just need information.
Okay. Yeah. Discord thing in the morning probably. I think we're trying really hard to get this done tonight.
Sure. Okay. Thanks.
Thank you. Sorry to keep you waiting.
It's okay.
See, I don't think I will be productive off or I will leave.
Okay.
So what's a key takeaway here? So AM, I know that. I understand because I fully understand what you guys are talking about. But PM, I got lost because of the two struct you're going to switch from.
Okay. Don't worry about it. It'll all be in Confluence. I'll write up a good doc maybe next Thursday or Friday. I'll put in like good diagrams. I'll make it color coded. I'll make it happy. I'll format it properly. I'll do everything the way it should be. And then you can go through it slowly then. Until then, you know what to do on Phoenix, PPM issue, and then into like just being careful with the tuning. You know how to plug in the battery. You can ask Hamza or Aiden or me how to charge the batteries. Talk to Connell about securing the drone properly on the rig, and don't take your hand off, or anybody's hand off actually.
Were you able to like get things spinning up? Is
Yeah.
all working?
Well, there's no PPM is broken. But we like the BFX 160 works. It seems to be giving okay data. I think one of the values for sensor fusion integration is wrong. Like the clock somewhere, like the clock timing is not right. Like it's not matching up, so it's probably not giving most accurate values. But we did sort of see motors spin up and then spin down. Small tests, which is pretty cool. So they now know what needs to happen to sort of plug everything together and connect it together. And so they can autonomously on their own, hopefully, safely do this. And we're gonna do it like without props first, and then like I'll come in or you'll come in one day and make sure that we're doing it safely, and then we can put on the props and try again. And like if the controller will be connected, so they can always just like turn it off, disarm it, and then unplug the battery, stuff like that. Plus there's prop cards, which is just so much safer than last week.
And I also think I'm gonna head out. But even though this is my first meeting about this aircraft, is a pretty good overview for me. So I also can work on the weekend. Is there anything I can work on, or stay with Yushin, work on the AM?
Yeah, if you and Yusha want to work together on that thing, I think that would be the biggest thing. Like, if we don't get Phoenix flying, we're not going to get auto takeoff landing done. And if we don't get auto takeoff landing done, then it's very difficult for us to have anything at competition.
Okay. Phoenix is a different aircraft than the Zero Pilot. It's that one.
So Zero Pilot is a software,
Yeah.
and Phoenix itself is an airframe.
This is Phoenix. Oh, this little one. Yeah.
Including the tuning rig. It's a system.
Oh, is it?
Mm-hmm.
Yeah, our aircraft are all named.
We all,
Yeah.
Balance.
Yeah. And,
Zero pilot is just two things.
and the hardware.
It is the hardware of like the flight controller and the software that runs on the flight.
Yeah, and I guess now there's loss as well, which is the other half of our software stack. So you've seen half of it today. There's another half for you to learn about.
Yeah, okay,
Yeah.
Yeah.
The
so far we have
everything
the,
below
Everything below this line we haven't talked about yet. Other than a bit of
Okay.
sensor fusion, and there's like a lot more to this than this is very simplified. So
wait,
There's-
we don't have the bottom half then, we have the top half then?
so we're only talking about this top half right
Yeah, yeah.
now. The bottom half discussion happened over the summer last term.
Okay,
Yeah.
and we get that part already.
Yeah.
Okay, cool.
Sure. Okay.
Thank you guys.
No problem.
Have a good night.
See ya.
Do you want a comfy chair?
Yes, I do. So, my thoughts here are, I convinced you that attitude manager should take one thing in as its input always.
Yes.
Now I'm questioning if we need to change that.
I'm sorry, using the jaw bra? Oh, it's okay, the mic is gonna be fine. But it's a lot quieter now that we're being pulled.
Yeah, okay.
I think you convinced me too far. Attitude manager should only take in one struct. It should compute that struct, and it should be happy.
What if? No, that's actually. Fuck. I was gonna say, what if PPM, or sorry, from PM? I know this is wrong, but what if, I was saying, what if PM, that input, is then converted into a controller output? But that doesn't make sense.
No, that makes complete sense.
Yeah, it's done in AM. Right?
What do you mean?
Okay, so the X, Y, Z targets, for example,
Mm-hmm.
we convert that into a controller output. This, like, the same interface that the pilot would give,
So,
which is what attitude manager should be doing.
So the funny thing is, if we do it perfectly, if we do the things that we want to do the right way we want to do it, the output you get from Path Manager should be in the same rough format of what the operator would give if you're flying in GPS mode, which is probably the mode you want to be flying in.
What does GPS mode look like?
In terms of
Like
how the drone
inputs from the
reacts.
pilot.
Oh, same like input, like up, down, left, right, but instead of saying I want to target a certain pitch, you're saying I want to target a certain distance to fly towards, which is what Path Manager quite literally does. And so,
So that pilot input is fine. It's okay. So why do we want to fly in like a manual level mode, for example? What is the benefit of flying in a level mode versus flying in a GPS mode?
one less computation on Attitude Manager, and the ability to get out of some situations. Like
Some
if
situations being
if there's just
like manual evasive maneuvers, is I assume what you're thinking.
that, and like your GPS hold is only going to be so accurate. I can see if you needed to fly like onto a landing pad, you might want to do it in level mode because your GPS mode is going to compute how much you're drifting and correct for it, right? Which is always going to be less accurate than and less predictive of the future events than a pilot doing it.
Right, but Attitude Manager doesn't have GPS in it, does it?
It's all on one chip now. It does.
Sorry. Sure, physically in the same chip, but like, Attitude Manager doesn't retrieve GPS data, does it? It's only local coordinates from PM, right? It's local translations, not global.
So the idea is that you have sensor fusion computing in loss, and everything above gets the data from loss. And so in that sense, Attitude Manager would get the full sensor fusion output.
Sure, but I don't think it's using it for like holding position. Like if we say hover, hands off the sticks.
Yeah.
If and we say we want to fly in level mode,
Mm-hmm.
that just means, I guess in my head, it's like something outside of Attitude Manager is telling it that inputs, like say we're drifting in the wind.
Yeah.
We actually want to be here, but we're drifting this way.
Yeah.
It's not Attitude Manager that says go back. It's something above Attitude Manager that tells Attitude Manager go back.
Does that require you to understand what plane you're in? Like what flight you have?
No, because it's the same format as Path Manager, right? Does like Path Manager is just giving local X, Y, like a local vector to go to
Yeah.
relative to the aircraft.
Yeah.
So to correct like wind drift,
Oh, I see what you mean.
you're just telling it to go back the direction the wind is pushing you away from.
Oh, I see what you mean.
So I'm saying like the controller, maybe even the big boy head honcho main ZB thread is in charge of that because it's in charge of what flight mode we're in. If we don't care about drift, we just drift in the wind. If we do care about drift, it calculates how far we need to go, or even Path Manager maybe calculates it,
I'm stupid.
right?
Remember when I told you that certain certain teleop commands would have to go through Path Manager anyways?
Yeah.
Because you do the GPS calculations through Path Manager when you do your stick movement. And you want the manual flight mode to exist so that you can do it in a non-GPS way. Like, to like offer you that control. And so, yeah, okay. Yes.
So we have something, say like controller class that takes in the inputs either from Path Manager or from the remote, and then decides what the data fed to Attitude Manager is. Attitude Manager always gets local directions, local coordinates.
I think it looks a little. I don't think we're using this one. I mean, actually, I can actually see this. We can watch it back later.
And so I guess what I'm saying is like from the perspective of the pilot,
Yep.
we're in fixed wing mode. I guess the controller manager, or whatever it is, takes the controller's stick inputs, like what you would normally have is like a manual control, but it's been, I guess, it's gonna be tuned, but it takes that input and maps it to the direction of travel of the aircraft. Right, so we want up elevator.
Yes. Okay.
So, okay.
So this part I think we're clear on where your inputs map to where you want to go. The part I'm stuck on right now is you have your controller decision module. That has to decide whether it sends it to Path Manager to compute and then Path Manager sends to AM, or if you just want to send it directly to AM.
I think that's state manager that makes that decision,
Okay.
because state manager manages the state, right?
So yeah, you have state manager. Why do you need a controller manager?
To do that mapping.
Could
of,
you
like-
not do it in state manager?
I suppose you could. I guess I'm thinking like.
It's like you do.
I suppose I'm thinking of like the controller thing as an internal component of state manager.
Yeah. To PM or AM? PM. AM. So like this kind of?
Sure. Yeah. Yeah.
Okay, cool. I just want to be sure we like have the ability to, yeah. Okay,
And so PM is the one that handles GPS mode.
yes.
It handles autonomous flight modes. If we bypass PM,
Yeah.
that means that we're flying in a manual mode.
Does PM also handle level mode? No.
No, I think by default, it's level mode. GPS mode would be holding ground
Right.
ground speed to 0.
I love level mode so much more as a term than attitude mode.
Attitude mode,
Or like I forgot what we were calling it last year.
horizon.
No, it was like an A something. It was attitude. Level horizon I think is a lot better of a term. Anyways, bypass. Level flight mode?
Can you clarify what you mean by GPS mode?
GPS mode would be like in a quadcopter. You've got
GPS mode will just give you a waypoint.
Oh, that one. Okay, got you. Okay.
Path Manager shouldn't have to do any additional work. This will be all managed outside of Path Manager, and it will just give Path Manager the relevant instructions.
Are y'all still on the
Yes, sir.
fuck?
It's been a long discussion.
My stream timer says it's been 3 hours 40 minutes.
Are you streaming?
Yeah, it's on YouTube.
My clock says that you should be the fuck to bed on a Friday night.
We're almost done. I think we figured.
What time is it? It's not that late.
It's 10:50.
It's not that
It's
late.
10:50.
Still, I went to bed at like 1 again last night. It's fine.
Okay, that's not a flex. You guys were in the call. I was, yeah. Okay, so we've essentially AM is like, is there anything else left to discuss for AM? It gets these things and it computes.
So, input is X, Y, Z magnitude,
Yes, none of this.
heading speed, no mode. Good.
Okay. And it'll just compute.
It does the compute. Does it get told when to transition between states?
No. It chooses when to transition.
Okay.
Okay.
Does that have any relevant effects on Path Manager? It does, the landing sequence.
No, it doesn't. Because if you're below a certain airspeed, it'll just transition to a quad. Right? So like even if Path Manager, okay, do we need loss here?
No, just erase it. You can erase those, yeah, as well.
This one as well, because we don't need it anymore. Okay, so Path Manager needs to know what kind of landing it wants to do, but the two possible landings that you can do are either you do this approach thing or you do this thing.
Yeah.
If you do this thing and AM chooses transition to quad, nothing happens because you'll be fine. Like the height that you'll be at when you're here is not going to significantly impact your ground effect when you're like in this zone. So it'll be fine. If you're in this way, there's no way you go fixed wing and then all of a sudden like drop out of the sky because you'll transition to quad mode. So TLDR, I think it's okay. If
So what happens if you're doing a normal fixed wing landing? Yeah. And then Attitude Manager decides because we've slowed down enough, it's time to transition to a quad mode as we're landing.
your quad can still fly forwards, right? Like, okay, so let's redraw this diagram. Your fixed wing landing has a few components. You have your glide in. You have this point here, which is some time, and then you'll actually just like stall almost and then land.
Okay.
From what I understand from my like 10 minutes of watching that YouTube video for advanced flight review. Up until this point, it doesn't really matter because you're not in the range of ground effect. And then this sequence will probably be, depending on how fast you are and what your altitude is, sort of just like land. So if you're in a quad state, you're probably slow enough that you'll either be told to speed up or pitch up and then land. And I think all of those are okay as a quadcopter to do. Like you can fly the quadcopter close to the ground. It's not ideal, but you can, like we've done it at competition, right? So I don't think, like it's probably not ideal, but you can probably make it happen, right? And like you could report back from AM to PM that you transitioned, and if this happens where you transition, then it just drops, or it flies this way and drops, right? I don't think.
So you're saying like Attitude Manager makes the decision,
Yeah.
but it can
Everyone's
also
still working.
report back to System Manager
Yeah,
what
yeah.
mode it's in.
You'll probably want to know what mode it is on the ground anyways.
Yeah.
So I'm saying like, there's nothing bad that can happen when you go to a quadcopter because it does everything a fixed wing can and hover. Yeah.
I didn't see what happened. It did not sound fun.
Yeah. Okay, cool. Cleared up. So I'll ask that you report something.
Sorry?
Report something.
It reports the flight mode, I guess.
Reports flight mode. And also.
No, not flight mode. We're using flight mode to describe GPS level, that sort of thing.
Aircraft's configuration.
Sure. Sure.
Yeah, I can go with that. Reports, aircraft configuration. Does Attitude Manager set the outputs for the motors? Or does it say these are the ones I want?
It knows the. So my current thought is the controls algorithms
Yeah.
for each configuration
Yeah.
can also have an output mix.
Explain that.
So it's like the desired motors
Yeah.
to use.
Okay.
So we'll have like which motors should be doing what as part of this like aircraft configuration.
Mm-hmm. Yeah.
And so there's no reason for that to be reported out elsewhere to the system.
Okay.
Except telemetry manager will want to know.
So this one, and then it'll actually set the motors here.
I think so.
Set motors unless overridden. Okay. So it'll report, but it won't. Okay, reports, aircraft configuration, motor outputs. And then I'll rewrite that one where it sets. Okay.
Is it useful to also report the error, like from your set point?
You can get that from the request from Path Manager and your SF stuff. I don't think there's a explicit reason for it to be done here. Because
Well, like it does the calculations though, right? No reason to do the calculations multiple times. Is it even important data to have elsewhere?
for each for each iteration of Attitude Manager, I don't think so. Like I would want to know at a very like a lower frequency what the error is on my path management. For this one, I don't really care if I'm like 2 degrees off.
Okay.
There's no way it'll be reported back fast enough, and nothing else in the system should care about it.
Good. We have Attitude Manager figured out.
Cool.
We have Path Manager mostly figured out. We didn't decide if it runs in its own thread or not.
We should just keep it threaded.
Sure. Keep it threaded because it is that way already, and
Also because I think SM might have you might not want to block SM with PM. Like just in case this one takes a while.
yeah,
Okay.
agreed.
Does this diagram still largely hold? Nothing we've discussed right now has changed this.
Don't think so.
Cool. We're almost there.
Telemetry manager.
Loss.
Is loss relevant to telemetry manager?
A little bit. I think it's important to leave this here in case you come back here in like a few years or like a few months and you're like, what is like, where does this go? It goes to loss. Okay. Telemetry manager. Do you know anything about what we want telemetry manager to do?
No, I know nothing, but based on the name telemetry manager, I interpret it as all input and output from the aircraft to all peripherals except like motors, all data streams in and out of the aircraft.
Yeah, that's about right. I haven't yet decided if it should contain loss, like the RC link. But I think telemetry management. Yeah, I haven't decided that part yet because it seems like it's special. Your RC link is special.
Well, something has to manage it.
State manager, assistant manager.
And why is it better to use system manager to directly get that data as opposed to system manager asking telemetry manager for it?
So that you could theoretically kill telemetry manager but still fly. You could kill, there's a world where you kill AM, TM, and PM, and you bring a thing home.
I don't think there's a world you kill AM.
Quick question. Why don't you just let the hardware do it? Like as we're currently doing.
Sorry?
Like, so the RC link is something that comes in over PPM, correct?
Yep.
1 second, sorry.
Well, I mean, I guess it comes in over whatever loss interface.
Yeah, it comes over the interface, right? And
Sorry. Yeah, so if it's just NTPM in there, you can just have it write to a buffer arbitrarily and just read that buffer. You don't necessarily need a meta. Giving the input, you might as well let the hardware do that for you as a service. Or maybe you just draw like a little buffer. Draw the don't see a reading capacity. It should just be a.
I didn't get much of it. Do you think are you able to type it out?
We didn't really understand like anything you said, unfortunately.
He's RC link is read only.
Sure.
No reason to keep it owned by a module. Also fair. It's like sensor fusion.
Okay.
It's a loss API layer. It's already been get in set for you.
Sure.
Oh, is loss gonna be a thread? We don't worry about it today.
Okay. Cool. So that's read only.
Yeah.
Oh, I mean, so is the instructions from CV.
The difference is that your PPM can be processed in the controller thing fairly simply. The instructions from CV might need to be processed by TM before being split into telling other things, right? Similarly, before you send back to ground, you want to synthesize data from AM, PM, and probably SM a bit, and to send back down. And so telemetry manager is there more so to gather and package data and then get and unpackage data.
Okay.
So it's like a lower priority thread, I think. Doesn't need to be a thread. Don't know.
Danny, how much is the nuclear debt, including tax and shipping?
Oh god, 30 something.
Okay, I'll put 50.
50?
It's for the form, okay, it's fine.
40.
Okay.
50.
Depends on the nuclear.
It depends on that. Like 30 is the upper end of nucleus. Like most nucleus
Because
are
we
like
allocated $300, so I'm gonna put 8.
do 10 times 30.
Okay.
Yeah.
Okay. Sure. So controllers, read-only interface. That's pretty straightforward. Cool. Telemetry manager doesn't need to run in its own thread. Well, it.
I think that answers the question.
No, we're gonna keep it on that module. Nothing sectors. Pull it. Nope. See bidirectional. Does.
It does. Yep. I draw the start.
Yeah, I think so. Look at that. All the modules are threads.
Just the way God intended.
Okay, attitude manager is a non-SM event loop.
Where does it? Oh yeah. Yep.
Non-integral M event loop. Path manager is a state machine, but maybe shouldn't be a state machine, but they're not changing it.
Yeah, I'll just FSM, TM, AM is event loop. This one, event loop?
No.
No, FSM? Okay, I'll let you.
It manages all of the aircraft state,
Fair point.
such as whether or not we're disarmed, or
I forgot about that.
yeah.
I'm gonna throw it in before I forget them. Control mappings. Aircraft state management. Okay.
Telemetry manager. It's gonna read in a whole bunch of data from the ground, maybe. It's gonna send all the telemetry data from the aircraft, GPS, attitude, motor outputs, maybe even the whatever, doesn't matter. Oh, data from all of the modules, most likely.
Yeah.
Okay. I doubt it needs to be an FSM.
No. Question.
Yes.
Sorry?
So it's going to get a whole bunch of data from the entire system.
Yep.
Can we write this out maybe?
Yes.
Probably the same way we've done it for attitude manager. It's like a list of steps. Collect data from the system.
I wrote again, is that okay?
Sure. We should specify what the system is from P0 pilot, because there are many systems.
You said it down.
G data.
Dad, it says it's a T.
Yeet. Okay. Get data from Zero Pilot. Send data to CV.
Okay, I'm gonna do it this way. Oh, it's just one for me. ZP, CV, ground. Send data to
CV and ground.
PM, CV ground,
Okay.
or
Uh,
PM, SM, CV ground. So ZP.
Yeah.
Wow.
Is it simple enough to just like go get CP, get CV, get ground, send CP, then CV, send ground, repeat? Or is there some other consideration? Like, is there, for example, the waypoints that we receive from CV? Is there any reason to take those and do send them to Path Manager sooner than if we were to just iterate through the other peripherals first? And I guess this is also assuming that all of this data is getting stored in a buffer that telemetry manager is just reading and writing to. Like it just reads from a buffer that contains all the data from CV, for example,
Yeah.
and
so,
then it writes to a buffer that has all the data from ground.
So these two come from loss, and these two will go to loss. So I think it's, oh no.
Just like loss write, or write to loss or whatever.
Yeah. So like CV and ground, the interface, like you don't actually care how it's being sent. You'll just say loss send this thing, and it like will do the thing where, and loss will supposedly do the thing where you give it this entire thing, and it'll send as much as it can, and it'll send as much as it can, and it'll send as much as it can until it's done sending, and so you don't have to worry about, like doing that.
Yeah, it handles the implementation
Yeah.
details for sending to device.
Yeah.
And similar thing occurs on reads, presumably.
Yep. So.
Hello.
He's probably like doing something and like the unmute button is just getting tapped accidentally. He was typing a while ago, he's not typing anymore.
I thought it sounded like Gordon. It's like,
He's not here, it's not Gordon.
okay, well, I'm also not viewing the call, so.
It's not Gordon.
Was it just Sahil and Neha?
Yeah.
Or was it just Neha?
Neha Trooper. Okay.
Hello, wait, you asked for a
I heard my name. What?
Bro.
Hello?
It's all good,
Hello.
you're good. We're just chilling.
Okay.
Yeah, Sahil, you're not coming through. Sahil, let's type. He's not actually, but he should be soon. So
Getting data from ZeroPilot, that's just reading.
CP data.
I think we should break it up into what is it reading?
CP data. Okay. So
Sinks and sources.
So I'm gonna go from ZP. So source, I guess. You have path.
Mm, remember, the only output from Path Manager is XYZ mag heading speed.
Oh, I mean, like, path manager is gonna generate.
Okay.
I
EC.
I saw what you said. I'm gonna finish my thought and then I'll deal with it. PM generates you this path with the waypoints. You might want to see where your drone is gonna fly.
Okay.
Fair?
So that's exposed? Like there will be an interface for that? I gotta think. Give modules ownership over what data they want to subscribe to and what data they want to publish.
So I guess what we could do is, you could have telemetry just have things that send to ground and send to CV and receive from ground, receive from CV, and zero pilot things just go, I want to receive from these datas, or I want to push to these datas. I don't know, I'm not sure if I.
So I guess like part of the issue there is we'll want to take CV data and send it to the ground. We'll want to take ground data and send it to CV. We are
Let's figure out what data we would want to send first.
I think Hill's trying to argue that we avoid doing
Oh.
that, build it to be abstract so that we don't have to mess with telemetry manager much whenever we want to add new data.
That's unfortunately not how it works. Because if you're adding new data, you're at some point going to have to send this extra bit of data to someone.
Unless every packet has, or every piece of data has a destination encoded into it.
Yeah, it's like.
But that's even more tied to the architecture
Yeah.
than.
So it's not necessarily the size up thing I'm thinking of. It's just like, if I want to send if I want to send something to ground and CV, and all of a sudden there's another device to send to. Then I have to change a lot of my code in a lot of places. Sorry, repeat the phone. Like, if I change where data is, if I change how data is flowing, I have to change a lot of code in a lot of places. Because telemetry manager doesn't have the ability to decide which one goes where anymore. Yes, no, maybe?
So, I think what he was saying is like, Path Manager tells Telemetry Manager, I have this data, or here's my data, here's where I want it to go.
Right.
And Path Manager will publish that data to Telemetry Manager. So Telemetry Manager just takes it and puts it in the appropriate place.
Okay. So then what if Path Manager doesn't give Telemetry Manager this data, and then we send it to ground and it just doesn't exist?
question.
Path manager never publishes the data. Telemetry sends what it has to ground when it's requested to send to ground. The data that from PM that is supposed to be from PM isn't there, and then the thing on the ground, just somewhere along that line of transmission, something gets messed up because it wasn't what expected.
Well, I think the idea is like telemetry manager won't send anything if there's nothing to send.
But like, you're sending packets to ground regardless from AM and from PM, right? How does the thing on the ground know what order it's in? Do we add headers to it?
Wait. Sorry, the packets that are sent to the ground,
Yeah.
they have metadata that like specifies what it is, right? Is it seriously all just like
It's literally you take this, you do the bit, and then you put the next bit, and you know how long it is. That's how it is right now. There's no headers. Okay. More signal noises. Yeah. Headers.
yeah, okay. That's
That makes a bit more sense.
what I just assumed that the
No,
system
we don't have. We literally, I remember someone was literally like saying, the first 13 bits are this, the next 4 bits are this, the 4 bits are this, the 4 bits are this, and then we send it.
that's not very scalable at all.
And that was me to Drew R. No, there was someone after you. There was someone after you who was I think it was Audie, who was redoing the like CV ZP communications, and we like did the bit byte thing. And it was just I think that's why he was coming after us for exactly what data we wanted to send across. Because he needed to know how much so that is the architecture as it exists.
Oh my god.
But the good thing is a lot of it doesn't have to exist anymore. So we
Just-
can,
Yeah, okay, so like we have packet type, it can be like
it's okay, simple. Yeah, headers is fine.
packet type, payload,
Yeah.
Variable length based on packet type.
Or we even just add a size.
CRC here. Well, if we have the packet type, we know how long it is.
I want to send down my path that I'm going to be going in.
Okay.
How do I, would I split it up into packets of U and 8s?
Yeah. And it would have like a sequence ID or something.
I was thinking more something along the lines, I didn't know, I saw that. I was thinking something along the lines of, you come up with sort of like you have a packet type, but it's like okay, packet type, header, then you have type, length, and then payload, and then you have maybe footer, which is just CRC, and then maybe something
End of
else.
frame byte.
For end of frame. This way? So I was thinking this way, and then you could define your packet type to be like common types like U and AT, or you could define it to be something that was like type path, or
so I guess what I'm trying to argue here is we have the type, for example, if it's a path,
yeah.
and then we have a fixed length for the path. And if we wanna send multiple pieces, like either we say like it is, a path will always be this many waypoints or whatever, or we say a path will be received with a sequence ID of some variety.
Right.
So you say like sequence ID, waypoint ID, data, and then you send multiple of those.
I don't know enough about what I'm talking about to argue for one or the other.
So I guess the only reason I'm arguing for encoding the length in the packet type is it saves a byte for all of the packet types where we don't need it.
It saves a byte for the data frame.
No, well, it saves the length byte.
Okay.
Because the majority of the packets will not need to be variable length.
The simple solution is this: you make that like part of the payload. So if you have a unique type, then you will check the next 4 bytes for length. Otherwise, it's just a payload, and then you technically don't need this either.
There's a reason that you put end of frame bytes in here. I can't remember what it is. I was talking about this at work like 2 weeks ago. It might be useless. Like, you know the length. It's not important. It's good to hear and read as well.
Oh, you need it. Not necessarily. I guess your waypoint sort of linked list could be a variable size. You might want to send that all at once and then have it decoded on the ground.
Okay, sure, you're fucked if your size doesn't match your expectation, but if it doesn't match, then like your whole protocol is busted. You can't trust anything. Like,
Beyond ideas.
if the size doesn't match, either like the payload is corrupted or your protocol is broken on one end.
Oh, maybe you have an
Right.
end of footer in case length corrupts and you reach an end of frame.
Maybe that's it. We've got like start of frame, end of frame thing.
Yeah. Because if something in here corrupts and you like don't necessarily, this will tell you for sure that this state is not what you intended to do. You off the
Start of frame, end of frame, CRC. Cyclic return. Yeah.
Sounds like special operating procedures. like, is there like a standard end of? I don't know. Okay.
I don't think this is relevant to this discussion though. The protocol that telemetry manager, or loss, more accurately, uses to talk with the ground or with CV.
No. Oh, I mean, it was relevant to decide that we could do this or that, and then the specifics of this and that we don't care about.
Okay.
Okay, so, left or right?
Both are possible, doesn't matter.
Cool. One of the other, one or two, either or. Decision.
And I think that decision is left to whoever's in charge of ground comms and CV comms. to define that protocol, right? But I think we need to set a limit on like, there definitely needs to be, it needs to be a robust system such that you can add and remove types to the protocol
Yep.
without like defining it in a
Yeah.
bit by bit frame structure.
This is good, this is good. Good to have before system architecture.
The only concern about like having an end of frame byte and not having the size is what happens when the end of frame byte shows up in your data.
That should never happen. But it could happen. But it should
Well,
never happen.
it could if you've like encoded a number into part of your payload, and that number just happens to coincide at the end of frame byte, right? Like say your end of frame byte is FF,
Mm-hmm.
and then you've encoded like a uint32 into 4 uint8s, and it's like, I don't know, some big number that ends in FF, and then whoop, you've hit end of frame. Noting this, I just transport buffer metadata at the beginning that includes the whole size. Yeah, so then again, like we just put the size in it as well as the start of frame and end of frame.
I think that's fine.
Okay.
I think
Doesn't matter, whatever. We can erase this. Like we don't. It's not important, right? For our discussion.
no. Do we need the space right now?
We kind of.
Okay.
Well, we're gonna have to figure out how does all of this go in and out of telemetry manager, and then how do we keep telemetry manager generic such that we can add or remove interfaces easily. Add or remove interfaces and data. What if telemetry manager is like a router or a routing system, where in telemetry manager what you're defining is like all of the data types that you can receive and the places that those pieces of data are supposed to go. And anytime you want to make a change, all you do is update that definition.
I don't mind. Why would you want that in TM and not SM, for example? Like places I want to go, I think would be in SM. Or no, I can see it both ways.
So it's like telemetry manager receives, or
You have to define globally message formats, and then after that you could receive and send to TM however you want. Like you could request data from it. Like you could request the most relevant, like most recent data of some kind, or you could push your data at some point, and then TM will just every interval just send and receive from things.
I don't mind that. Like defining an interface basically to telemetry manager, input interface, output interface.
At
And
that point, it's
everything.
almost like it should be in loss.
Well, and then everything publishes to that interface.
I hear voices.
Let sender have control over where it goes. You actually don't need to globally define it. Yeah, I think he's right about that. You don't need to globally define it.
Should TM be in ZP at this point if it's an interface?
I think so. So like, I think you heard the word interface and loss alarm bells went off in your head.
No, I'm just thinking you're starting like you're starting to use it almost like you would loss link, where it's just like a buffer, you're reading from it when you need to, and then you're pushing to it when you need to send it the other way, and then it'll do all of that for you, right? The only thing is, if you leave it in zero-pi software, I guess you have more control over like making sure it sends, out of like all the data together, or something. But if telemetry manager doesn't actually have any control of what it's doing, it's no longer something that needs to be in software. It can just be in loss. That's what I'm thinking. I'm still not completely sold on the fact that telemetry manager doesn't have control over what it's doing. Not sure. And especially since like, you don't need telemetry manager to send between PM, AM, SM, right?
Yeah, PM goes to loss and asks for waypoints.
You would probably say lost lem. Oh. All your data coming in is going to be in a jumbled mess. No, I see what you mean. I see. Because you're grabbing data from a whole bunch of different places, assimilating it, and then distributing it. Yeah. I mean, you could make an argument for that part of the code going into state manager, like the put together and distribute, and then the grabbing buffer part goes into loss, I think.
I'm gonna.
Oh man. Okay. The voice chat is just simple going on, now. Someone's gonna read through this and be like, I'd imagine you might get commands from ground station that also need to be processed by that controller mapper, I guess, or whatever we call it. I can't read it, but yeah.
Mapping?
Mapping, sorry, controller mapping. But then you just let SM subscribe to that data. That's true. I like leaving it in zero pilot, to be honest. It makes it slightly less confusing for me. That's all. That's the only reason. Is that me or is that you?
No, it's
Okay. Me? You. Now that you mentioned it, it death belongs in loss. LMAO. Why do you do this to me?
If we're making it like a publish and subscribe messaging interface, yes, it belongs in loss. If it's like,
If it's synthesizing data,
it belongs in
it belongs in zero pilot.
zero pilot.
So those don't make it synthesized data.
Well, then what does?
You need something to sort of gather your data together and make it easy to grab at once. Otherwise, you're calling many, many functions to get data, right? Because everything that goes from the ground to the air needs to go through our system, including any data that wants to be passed to CV from ground, if that ever needs to happen for whatever reason. And that's not something LOS should be doing. That's something that you want telemetry manager to say, you know, like, we're going to send a packet to CV in this much time. It's going to include all of these states and this data that the ground wanted to send, and it's going to prepare that and it's going to send it. And it's going to receive.
Him.
Sorry? Okay, I can stop now. We're good. Easy. But like, so it needs to be able to do that, and that's why I didn't want it to like be like. That's why I wanted to be able to manage its own things. To some extent, at least. Like you can still like subscribe to certain data, but you need TM to process some of that data together to get it right, because you'll get waypoints maybe from the ground or from CV.
So are we having this discussion? It should be in LOS. No, it should be in ZeroPod, because telemetry manager, as we're describing it, needs to be broken into two separate things. A piece that's in LOS,
Yeah.
and a piece that's in state manager, maybe?
I think yeah.
Or system manager, or whatever.
System manager. Can we just rename it to ZP manager? Would that make it less confusing?
We can just rename it to ZP.
No, but ZP just has the whole system.
ZP, or ZP, or ZP.
Okay. Yeah, I think part of it being in system manager is okay, because if the large bulk of like the waiting and receiving is done in the LOS, and system manager can just quickly stitch and send, it's not going to block. I don't mind carrying this. I don't know. I need to pee. Be right back.
I will sit here and pretend to think. I don't know what all the LOS interfaces are. Okay, bye Sahil.
Sorry?
Talking to Sahil, sorry. He's on the
Yeah.
watching the stream.
how close are you guys to them with the planning, obviously?
We have figured out what attitude manager is gonna look like. We know what path manager is gonna look like. We know the data that's going into attitude manager. We know the data that's coming out of path manager and going into path manager. We do not know what the hell telemetry manager looks like.
Okay. What does SM stand for? Site System Management?
Yeah, system manager.
Oh, okay.
Yeah.
Okay, you guys are getting close. Oh, Eddie,
So,
Yeah.
can I, oh, sorry, you can go first and I'll ask Eddie. What were you saying?
sensor fusion lives in loss.
Yes.
This publishing model means that sensor fusion would have to publish to something that's for pilot.
Alright, Eddie, can I borrow your camera and take pictures of that in various angles so I can get a good digital model of it for insert?
Yeah, you could. I don't know if you'll get good results.
Oh no, I'm gonna like manually trace and stuff.
Is Lost a publishing model? Is Lost like a publishing model now?
Well, I think Sahil is just very inspired by ROS these days.
Lost?
Robot operating system, I think.
Oh, where everything's a publisher and subscriber?
Yeah. I don't know, I've never used it, so I can't say, but,
Just-
almost certainly that's where his ideas came from.
It's, if you're building gates and like wire logic, it's so much more complicated to make things publish and subscribe than it is just to make things. Subscribing is just really difficult to do in digital logic. Because you can't actually, like there's no class that's like this thing dot, like you can't like, you have no idea of the other thing. You have to go to the other thing itself and force it to, okay, everything's a publisher. There are no subscribers. Everything's a publisher. Like, okay, so. In loss, there are things like loss comms and stuff like that that, you know, can send back and forth. You need to send telemetry data to the RP900s, and you also need to communicate to CV, right?
Yes.
Once those two have been sort of determined, that means that the zero pilot part of telemetry manager prepares a ground data and an airside data. It's going to prepare that by getting information, or like having information pushed to it from certain states, and it's going to just compile it together, or like string it together and send it. Because, is that reasonable? Okay.
I'm just sort of wondering, like, what's the benefit of pushing it from those to telemetry manager as opposed to telemetry manager getting from them? Like, where's the benefit in that?
I like getting from I like it where telemetry manager gets it, because then the other programs don't have to care about what telemetry manager is doing.
Exactly. I mean, they just have to provide an interface. Sahil is gone.
No. Okay, yeah, they just have to, yeah, like.
They just have to provide an interface for telemetry manager to grab the data, or anything else that wants the data to grab the data.
Which they're going to need anyways.
I think the thing I don't like about each module pushing to telemetry manager is they all then need to know about telemetry manager, and you have to incorporate anytime you
I'm
want.
gonna do it on my laptop. I'm just gonna give it so that you can give me the files.
Sorry?
Cause you said there might be sketchy stuff on it.
Oh, you could just leave it in the camera. I'll do it when I get home.
Okay, thanks.
Yeah, no problem.
So like so each state that isn't telemetry manager would need to handle, or would need to know about the existence of telemetry manager for one.
Yeah, it's not great.
And then would need to prepare that data and send it, as opposed to having an interface for anything to receive it, or to like grab it. So
Okay.
in the case telemetry manager just reaches out to the various things, grabs the data it needs, and sends it to the places they need to go.
That's fine. That's not hard to make thread safe. Because you can just, yeah, that's fine. That's easy to do. Probably easier than pushing to telemetry manager. And that means that telemetry manager really can be a state machine, or it can be an event loop, because it just grabs from places, sends to places.
And I'm thinking ideally here, we have like,
No, wait. Does it send to places, or does it leave it available for places to grab?
so telemetry manager grabs all the stuff and then packages it into a nice bundle for the loss interface to grab.
On the return, so it gets things from the ground from CD. It packages that up. How? For one question, and then secondly, how does that data then go to, like, if I got new waypoints from CV and new waypoints from ground, but my command from the controller was to use the commands from the ground, then like how? Someone needs to decide which one to use, and then someone needs to package it up. And I'm thinking that whoever, like the person who's deciding which one to use would be the system manager, but I'm not sure about other data that might, you know?
Yeah, so when you said that, that brought me straight back to that discussion about, or that comment I made to Time about does Path Manager push directly to Attitude Manager, or does it push to State System Manager, which then talks to Attitude Manager?
I think it's fair that everything goes through system manager. That sounds like something system manager should be allowed to do in C. And I guess that also then, by extension, means that TM only needs to talk to system manager. Oh no. TM only needs to give to system manager, but it can grab from other things. Because system manager is the one that's deciding, are you running path manager, are you running attitude manager, how are you running these things? And so, I guess you could have, telemetry manager could have this sort of like pass-through data option, so like ground to CV and CV to ground could just be passed through without going to the system manager, but otherwise you can just give it to system manager, and system manager will decide. Because it's going to get things like, it's going to get quite literally an RC input, ground station input, and then CV input. And it's gonna decide for what to do with these.
What if telemetry manager, you push data to it, and all it does is it reads the data that it received, and in that data there is a destination, zero pilot, CV, ground. So all of our systems, when they send data, also send a destination.
Okay.
So then telemetry manager, all it's doing is reading that and routing it.
Okay.
And when data gets routed to zero pilot, telemetry manager sends it to system manager. System manager is the application with all of the logic that tells all of the things what to do. And that's what changes primarily over the years. So like we're essentially addressing, or we have an address for everything, or every piece of data that's sent between the various subsystems. What am I writing?
Telemetry manager routes between things.
So, to add a system, we would need to define, what the system's input is, what the system's output is. And that's it, right?
Yes. Because you don't need anything else to know when to put something. You don't, yeah.
You would be reading from that system, and you'd be writing to that system. So telemetry manager, all it knows is the data that is received.
Do we have two black ones?
There's black one here.
Two black ones? Nice.
That's all it
Pop
does.
off now because I'm waking up in 4 hours.
Alright, see you, Neha.
But yeah, see you.
The system manager, so system manager handles interpreting and routing the data in zero pilot.
Okay.
So the systems for this current architecture include zero pilot, CV, and ground.
Yes.
We should do that with
Oh.
Oh,
No. I was gonna say, do you wanna say like ground station? Ground antenna? No, you don't, because the ground station was ruled out. Yes.
it's
all one interface.
Yes. Don't overcomplicate things, make it simple, be happy.
This is incredibly simple.
And it can just be a loop.
Yeah. All it does is read each.
One caveat, let's say I want to send, let's say I want my waypoints to be sent to ground and to zero pallets. Would I route it to zero pallet and then let zero pallet route it to ground? Or would I send 2 packets? Or would I mark 2 destinations?
My gut says 2 packets, but that's inefficient because you're duplicating the data you're sending. Actually, my first thought was encode somehow both both destinations into the same piece of data, like multiple addresses.
It's not too difficult because you just, like instead of like if you had header and then payload, this one can be 8, not even 8 bytes. It can just literally be, it can be 1 byte, and that gives you how many destinations total. Like,
Or, better than that, you just have a bit field defining each destination.
yes. So it'd be like 1 hop.
Sorry?
So it'd be like CV ground ZP.
Yeah, exactly.
Interesting.
And so if you want to send to ZP and CV, you toggle those bits. If you want to send to all 3 for some reason,
Okay.
which is silly, you do that.
So now, knowing this, does PM talk to TM to talk to AM? Or does PM just talk to AM? My guess is just let PM talk to AM.
Yes, but I was actually wondering, does PM talk to SM before talking to AM?
Yes, it should. PM talks to SM. So,
Everything talks to SM.
yes. Force SM receives from SM. All managers forward to SM and receives from SM. And then TM this.
Okay. So, we have all of the individual modules, the managers. Now we define SM, right? Okay. This is, I think this one we don't have to worry as much about being agnostic to anything, because this is the one that everything, all the specialty is encoded in. Okay. Can I erase this, you think?
telemetry manager routes data between systems,
Here, let me-
receives data from all systems.
I'll rewrite it here so I don't.
Okay.
Almost.
Or the other whiteboard that has path manager on it.
Yeah.
No, this is fine, never mind.
Okay, that's pretty much all it says, so. Read browse data between destinations. Okay, and then I can move this one.
Do we need those blocks anymore?
I think we should do a lot of our stuff sort of just,
Emanates from them.
yeah.
Cool. What does system manager do?
Hey Andy, if
Yeah.
you have some time, can you quickly look over the MEF outline for the application? So I just put like 10 people leading the project and one Matt. There's Mihir. He's doing like the CV, like the thing, right? He's a CS student.
Yeah.
And then there's me, but I just put one. And then I took these as like approximate numbers. I don't think it's like a massive deal. And then this is our current team fund situation. We're gonna be asking for 3K and then talk about who we are, do the UAS competition.
I would ask Jenny what number she put last year.
I counted, we had around 3,000, that's why I used 2,000. It was like 20.
No, like numbers of students and stuff.
Oh, she doesn't have it.
Oh, okay.
Then I gave like a breakdown of doing, yeah. That's fine.
Do you wanna say maybe like it's embedded for software to the VFS using online?
I've mentioned the verify software here in the past, and then in the supporting document, I write like full thing, well, I don't actually, but I break it down more specifically. Because giving like a whole account of 20 to 50 for them, I don't think they're a big fan of, so I,
Yeah, that's fine.
and then I have like everything. I like IMAX, Gantt chart, the online stuff, notes, like the comps, and then eventually I'm reading outcomes as well. So that they can like see all the
That's actually, imagine, our planning finally came into use. Imagine, that's ridiculous.
Sorry, what planning can you use?
Like all of like the ConOps planning and
like
stuff.
all of the assistant, like everything on Jira, I just exported everything into a single PDF. It's like a 15-page PDF, and I'm just giving it like a like supplementary information, basically.
Cool. That's questionably good material, but
Hey, they're not gonna read it. They're
until
gonna like
they
skim
do.
through it and be like, wow, these people really know their stuff. Let's give them all the money. Obviously, I'm being hyperbolic.
Okay, this is what I got. Controller mappings, flight modes, aircraft state, and instructions to all other managers. And part of that is the data that goes between the managers. Is that everything?
I don't think, I think we. Aircraft state, interest match, measures. Aircraft state. Okay.
These are like round to zero.
Oh, I see, because it doesn't actually do the.
Zero pilot doesn't do the routing to attitude manager or path manager. Like, so CV data will come from telemetry manager to system manager.
Yeah.
System manager will interpret that and go. path
Right,
manager needs
and
that.
then TM will grab from everything and then, or, no, people will push.
System manager pushes to telemetry manager.
Okay. Okay.
And in that regard, should it be a zero pilot interface or not?
It handles logic.
The logic it handles is just where does data that I've received go, right? It's going to be calling the loss interfaces for writing and reading stuff. Although, I mean, so does sensor fusion, so.
So we're not making that TM grabs from everything individually anymore?
I don't think so. I think system manager pushes to telemetry manager this data that it deems we want to send to ground or to CV. Does CV ever request data? Like, do systems have,
Yes.
is this a push-only model? Or this is a push-only model?
CV might request things like, can I get position?
What if we just constantly send position? Sorry?
You're sending position, which is pretty huge already. You're sending undefined just yet, but you're sending something along the lines of waypoint or intended direction of flight, so they can sort of use their algorithms to sort of determine what to look for. And then you're sending things like battery life, flight status, a lot of random stuff. And like the communication link between the two, between the nuclear and the Jetson, or the zero pilot and the Jetson, is not that strong.
What is it?
Bidirectional UART, from last I heard.
Well, bidirectional UART, okay. Presumably, you just set the baud rate, like if the baud is set to like 9600, sure, that's slow as hell. But
Wait. Baud rate that you're using?
Sorry?
What's the baud rate that y'all are using?
We're not sure actually. I don't know. Do you know?
No, I have no idea. I'm not sure if it's even defined.
Okay, but how is it slow? Like, wait,
Yeah.
I'm very curious how we got the it's too slow.
I don't know.
It's just a lot of things to push.
Yes, but even though there might be a lot of data, frequency is also important, right? If you have to push a lot of data very fast, then that's a concern. But you can push a lot of data at like a comparatively low frequency, like 10 hertz is perfectly fine if the Jetson can actually keep up at 10 hertz.
That's
right?
sort of what I was thinking as
frequency.
Like, also on the ground, we could probably operate at 1 hertz on the ground.
Yeah, like what does Mavlink push it to? I think Mavlink is like 4 hertz, 5 hertz? Like you don't need to push this fast. The only thing that needs to be fast is logging. And even then fast is questionable. Like there's a requirement for that, but there's no requirement to communicate fast at the Jetson or the ground station. These things don't have to be real time. Or not real time, sorry, they don't need to act fast,
Yeah.
right? 10 hertz is more than fine.
And the other piece with logging is we'll actually have onboard logging systems for. Oh no.
Oh, you want to know what's actually really clean about putting TM in the center of all of this? Your logging can just tap into TM. So every single message that Zero Pilot sees, you can just send to logging, like without a care in the world, which is actually very clean.
Very good point.
So it's like a tap on every single message that you
That's
receive, if you think about it.
Good
But
point.
anyways, that's a side benefit.
Okay, sorry.
So I don't know how much you've seen or heard since saying you were gonna leave.
Nothing. I actually did leave. I'm very surprised you're still here.
So almost there.
So the thought we've had at this point, all of the data that goes between the systems, ground, CV, Zero Pilot,
Mhm.
has an address in it, like an intended
Ooh.
recipient.
Hmm.
And it's one hot encoded, or not one hot, it's just a bit field. My brain's gone.
Implementation details, but
Yeah.
like, the thought was that everything has a destination. Stuff that is destined for Zero Pilot, telemetry manager passes off to the system manager to deal with.
Like, the thing I'm okay. The thing about addressing is, for a second, okay, let's imagine it like this, right? Like, have either of you dealt with like UDP, like networking, where you just deal with like UDP multicast streams at all, where they just dump data at you?
No.
No.
Any?
No.
Okay. Crap, that ruins this.
I mean, you can
okay.
try explaining it, and I can see, but
Like,
Mm.
I'm familiar with
No, no,
Okay.
no, I'll use something else. Basically, like, what I'm trying to get at is I want to try to move us into an architecture that treats everything as global, and or at least all of our messages as global. And here's why. Say if what this inherently does is that say if we need to add in a new module that does X, right? And this new module X needs to care about our GPS and needs to care about our battery voltage. I don't know, I'm making this up on the fly, right? But say we have a random module that needs to care about these two things. If we move towards an architecture that's generic, like we are moving to an architecture, right, where telemetry manager is generic and handles sending messages between things. Actually, this is a bad analogy. We should be using something between the Jetson and ground. What I want to convey is that I want to put us in a situation where all of our messages are effectively global and they don't have to worry about addressing. Because it means that if your module ever needs to care about needing another message, you no longer have to worry about going to the transmitter of that message and adding in another field and transmitting the message twice with an address. What instead is going to be more scalable, I think, is telemetry manager handles the callbacks for all of these. Like you can register a callback for a particular message, and telemetry manager, when it receives a particular message from a publisher, fires that message off to particular subscribers. It makes it really easy to then make modules subscribe to messages that they need to care about, and adding in new modules becomes as scalable as just registering a callback, and telemetry manager does the rest. This way, you no longer have to worry about addressing. You no longer have to worry about any of that. You trust that when you send a message, telemetry manager is going to take care of getting it to the recipients. And then you don't have to worry about that, right? So adding in modules becomes very plug and play. Does that sort of make sense?
Unfortunately, yes.
Okay, you can. I fear the unfortunate. I hope you see the hugely like powerful benefits of this though. Like freaking hugely powerful. Oh no. Hello?
We can, okay, so we still need it so that you can pass data through from ground to CV and vice versa.
Mm-hmm.
Um,
How does the CV data pipeline or CV ground pipeline subscribe to each other?
Simple. They don't need to. There's like what I'm inherently trying to get at is an architecture where effectively your messages are global and they can buffer each other. Now there is actually an argument to make against here that you can make, and I'm going to make it against myself because I'm not sure if it's the right call to move us into these, but I still think addressing is the wrong call. I don't think we should implement something with addressing. But the other call is to, well, it goes back to that original message you mentioned, Anthony, where it's like, okay, how much data can we really send? We need to know that number before we can really go further. Because if we physically don't have enough, because we need to know how much data we can actually send under this messaging scheme, and that's going to be a huge factor. Because if we have limitless amount of data, then yes, we should be doing something that scales. But if not, then addressing might need to be the play, or we need to implement something as that because we physically won't have a big enough buffer to maintain all these messages as global. That's the counter argument. And it's kind of an important question to know when we're architecting telemetry manager, I think.
okay, I have a question. How important is the architecture of telemetry manager for system manager right now? If I just say you can get the data you need from from telemetry manager through system manager, it's either going to be subscribed and pushed to system manager, or you call it and you get it when you need it. Does going between decisions of how telemetry manager is implemented severely impact the outcome of how you architect system manager? If you just know that the data will be there from TM and from TM somehow, some way, yet to be determined.
Nope. That's exactly the point of black boxing. You can say that it doesn't matter how you implement it, as long as you guarantee that that TM will give these callbacks to data. So it does not impact SM architecture.
We've determined that SM is going to get something from TM and will send something to TM, and all of the internal zero pilot communications will internal zero pilot communications, whatever.
Yeah.
We'll probably go through SM, but probably through SM. But anything that's external to zero pilot will be SM sending to TM or SM receiving from TM, and then TM will handle sort of prepping everything and then sending everything, and we don't need to figure this out just now, tonight, right away.
Yes.
Right?
I would 100% agree with that. That's why that's how you know your architecture is good, is when you say it doesn't matter how you implement it.
Yeah. So.
Yeah, wait, what the fuck? Isn't it 12:30?
Yeah.
Yeah.
What the hell?
12:24.
Close enough.
We've been at it for 5 hours now.
Holy
This is a long
fuck, to
YouTube
get
stream,
some
man.
food. It's a
Yeah.
boba.
Okay. System manager. Boot. This is the start of the FSM.
Okay. It's an FSM now. Yes, it is.
Okay. So we boot the system that starts up whatever.
You might want it big and maybe in a blue or a black.
Okay. I'll put boot over here. Boot. We boot the system. Spawn all the threads as appropriate. Then, fetch instructions.
Yes, sir.
disarm mode.
Arm disarm. And then you will have, it'll do this thing. It'll do, does it do control mapping inside fetch instructions? I think it does.
Fetch instructions would also process the instructions.
Yeah.
So yes.
So this one would be from TM link.
Sahil?
Yo,
Yeah, we are closer to like 33, 34 fill out for the form at the moment. Most
Nice.
likely we can get to 50 if I try hard enough asking more of the people from the other design teams. Have you reached out to them yet by any chance?
yep.
Okay.
Reach out to a few of my friends on those teams. We got it like posted in a few places, but I would also make sure like maybe do another ping tomorrow morning or something.
Sure. We emailed them a couple days back saying that we're gonna send them the form details by the end of the week. Do you think we should send it tonight or tomorrow night, or what do you think?
I would honestly just send it Monday.
Okay.
As a bypass?
I would just I would also just send it Monday. Like they're not going to be working on the weekends.
Yeah,
and
that's fair. Okay.
just make sure you send it like first thing Monday morning.
Sounds good.
Like
I'll do
even
that.
like you can also just send the email.
Yeah, I'll
with the
schedule it on
information.
Sunday for like 8 a.m. on Monday.
Yeah, perfect. That's all you got to do.
All right, sounds good.
Sweet. Nice to meet you, Hamza, and actually talk with you.
Yeah, nice to meet you too.
We disarm. And then the arming, I think, is a separate action. So like, we don't go from boot to fetch instructions. We go from boot to disarmed. We start disarmed. We are disarmed unless we've said otherwise.
I'm okay with that.
Sorry, could you remind me what fetch instructions is doing in this context?
So,
What if we change it from fetch instructions to compile instructions or like process instructions?
I think that's more accurate. So we're talking, it's like collecting the data from the ground station, from CV, from the controllers, and then performing controller mappings and then deciding, does PM get these instructions, does AM get these instructions?
Okay.
Essentially.
Is this the FSM or the event or the event loop? Out of curiosity.
Trying to figure that out. So the responsibilities of system manager at this point are map controls, like controller mappings, manage the flight modes, and manage the aircraft state, and send instructions to all the other managers.
Oh, system manager. Oh, is system manager going to be doing the switching of the flight modes, not AM?
Yes.
Okay.
And
Depends on how you define flight mode.
yeah, so flight mode being a level mode or a GPS mode or acro mode. I don't think that AM architecture would support that. Maybe
We could make it. It would.
but whatever. So that's all that the
Mm-hmm.
SM controls. AM
Makes sense.
controls like the aircraft configuration
Yep.
and will decide what output mappings to make. So like if we're in fixed wing, it will be flying along, and then say we want to slow down, attitude manager makes the decision to transition into a quad rotor configuration on its own.
Okay.
So yeah, the system manager is more about like what does the pilot interface look like? Versus
Okay. Yep. That makes more
attitude
sense.
manager being like controlling the aircraft based on the inputs from the pilot or whatever system.
Hmm.
And system manager chooses what that system is.
Makes sense.
Sorry, I just had to remind myself. Okay, process instructions, and that it does this. Okay. It chooses to go to.
Yeah.
So I'll draw. How do I want to draw this? Which one do I want to go? I want to go this way. Or this way. I'll just draw this here. PM. I can go to here. I can go to AM. And then
Do we not do that and instead do autonomous flight landing? Or sorry, like, so I'm thinking, my head is thinking right now, we have boot mode, disarm mode, arm mode, failure mode. Or states. Boot state, disarm state, arm state, failure state. Right?
yeah.
And we could have, I'd say, the vast majority of the processing will happen in the arm state.
Which is this one.
Yeah.
Okay.
Disarm will like still, actually, what does disarm do? Make sure the motors are off?
Yeah. And it probably also communicates at lower power and stuff.
Yeah. Probably. Attitude manager won't even be running.
No.
Like attitude manager will, I think will spawn an attitude manager instance when we arm the aircraft.
Yeah.
It's like it just won't be able to do anything unless we're actually armed.
Yeah. You also do things like telemetry management. You'll do it at a lower, like you'll do less stuff transferred, to prevent things like radios overheating. You might choose to transmit at a lower power if you have the option, stuff like that. And I think that one's no longer process instructions. I think that's just armed.
I think process instructions is just a function
Yeah.
that is run. Do we have an intermediate sequence? Disarm, arming, arm? Like, do we have like a series of steps and checks that like a state will just like
I think
run
that
through all
should be,
those
I
checks?
think that should be a requirement of, at the end of it, like before you move to arming, I think you would do that. Cause if its only purpose is to go from one state to another, after doing what it needs to do, it can be included as part of the state.
So, what I was thinking was like, you've got disarm, and then you go to arming, and arming, it's like you flicked a switch or something to like start up the aircraft.
Yeah.
And then arming will check, are we upside down? has the button been pressed? Has the whole list of pre-requirements been met?
Yeah.
If it hasn't, we kick back to disarm. If it has, we go to arm.
So the decision happens,
Basically, I'm
Three.
saying we don't need to check all of these other things unless we know we're about to try and fly. I guess you're saying just check it before you move out.
yeah, so like you'll like, so you're supposed to check it like as you're moving.
Is it as simple as that?
Yeah. Maybe like, no, you're fine, yeah, that's it. Cause everything inside ARM can just be loops and ifs and stuff. And it doesn't need to be complicated. Especially since everything else is threaded anyways, so it'll keep computing even as long as, yeah, that's good.
So, the flight mode, controller mapping stuff. That all happens in here exclusively.
Yes.
Flight modes, controller mappings, aircraft state. Yeah, that's all just stuff that we only do when we're armed. Sending data is done asynchronously through publishing to telemetry manager, so we don't have to touch that really.
No, you don't have to worry about calculating paths because that's done asynchronously. You don't have to worry about motors, that's done asynchronously. So all you're doing is basically just managing the state of the aircraft.
Only thought is path manager. Path manager does it just continuously output data? Does system manager like push requests to path manager and then receive that data back and then send it to attitude manager? Because in my head, attitude manager lives entirely in ARM.
Right. I think Path Manager can live entirely in ARM as well, no? No, it can't. It needs to exist in disarm in case you want to like pre-compute a bunch of stuff, and then verify it's good, and then ARM, and then fly.
Let's say we arm. When we arm, we know we're going to start by not moving. So then Path Manager starts computing stuff.
Yeah.
Wait, how do you know when you arm you're not going to be in a not moving state?
We won't arm unless we're not moving.
Oh, what if you disarmed mid-air by accident?
Remember, we have
have to have the.
If you
opportunity to
disarm
be able to do
midair by accident, I think
that. No,
you-
we don't have to do that. It's competition requirement that you can disarm it. You have to be able to do that.
No, it's
That's
competition
fine,
requirement
but
that you
we're
have
talking
to be
about
able to
turning it back
disarm
on.
it. But then the question is, there's nothing saying that you can't have functionality to rearm it. It just needs to be able to disarm.
Yeah,
And
we're
you
not-
can control it to
we are
disarm
not
is the
talking
competition rule.
about losing aircraft link.
Okay.
We're talking about physically flicking a switch and saying, shut off the motors. It's safe to go approach the aircraft.
So then,
So my thoughts on this are the arming sequence should be like, we are off, we are on the ground, we will only arm if we aren't moving, we are upright, someone has pressed the arm button.
oh wait, yeah, you can't rearm without the arm button. You can't rearm without the arm button. And I better hope, and you'll be stationary if someone's pressed the arm button.
Does Zero Pilot have an arm button?
Sorry?
I believe it does in an external
It does.
connector. I believe that's what we
Yes, it
discussed.
does. We architected 3.0 to have that.
So, okay. So my question is, if you're flying somewhere and you disarm it, let's say you want to be safe and you want to let it so that you can turn the drone off while something is happening in the air. You would,
Mhm.
like a plane flying by or something, like you just, like pilot panic and like disarms the drone. You have to walk out there and rearm it by pressing the button again? Or is it okay that the button has been pressed and then you're just waiting for the switch?
I disagree. I think it needs to be the button pressed every time. Because you shouldn't be disarming this thing unless you're in like a fucked situation. Like what other purpose do you have to disarm the aircraft aside from
Well,
you are landed
okay.
safely or you need to turn it off because you're just fucking up?
We will need to have rotors off to complete landings.
But that's a switch on the controller. That's not exiting the armed mode.
Yeah.
That's saying to the flight controller, I am like like you press the button first and then you do the switch on the controller, right? So the button itself is arming. Oh no, the switch is also arming.
Yeah. In my head,
Ah.
it's both the button and the switch
Yeah.
in conjunction. So you've physically confirmed on the aircraft and you flipped a switch on the remote. You have both
Maybe-
systems work before the aircraft starts.
Maybe any solution of like a soft disarm state might be worthwhile here. Something that we can command, like some sort of channel that we can use to soft disarm, or potentially or what we can do is we can turn that button as well. We can also make it such that we can arm or disarm through the ground station potentially, because you'd have to be okay living with the latency of that, which could be fine. We land and then the rotor spin for a second extra, and then it processes and it enters into a soft disarm state, which is commanded via the ground station. And then a hard disarm state is only entered in through if the button is not pressed or you flick that switch down, and then you have to do a full rearm. It's not necessarily complicated. I feel like there's something cleaner to cut the rotors off, but I don't know.
You could just give added. You could give it like. Your system manager can technically override attitude manager, and
It can do whatever the fuck it wants.
And it can just say, I'm in ground operations mode right now.
I'm armed, but I'm in ground operations.
Yes.
Yeah.
Yeah. I think we're coming to a pseudo consensus where it requires adding an additional state just to the right of arm. It's still what we would classify as in it's in a hierarchical design. We're in an armed state, but this is, even though we're in an armed state, we're in a fashion that in effect still disarm. We're in a state that still disarms the motors.
Do you see here how you're doing this controller mapping, and then you're choosing to go PM or to AM? You can just go to something else here that's none of the above, which is just.
Sorry,
soft
wait, is
soft.
the SM state machine on the right, or is is the SM state machine what Aiden's drawing?
Aiden's drawing a proper state machine. This is something that we like. It's not actually a state machine. It's more like a decision module as part of.
Oh, like the event loop that occurs in like the key,
and
like
it
the
chooses
key
to do
flying
this. It
state.
can also just choose to like not do PM or AM and just do like soft stop or something.
Yeah, I think it would be cleaner to implement this as its own state rather than a decision, rather than something on a decision tree, because in ground ops we may still want to have control over the actual pusher props, right? We may want to be able to taxi. That's something that doesn't require AM input, and it shouldn't really, but it is something that requires access to the motors and requires us to have passed in the arm state, which is its own state transition.
Could literally just draw that as another, just two more states. This is like that soft disarm state that I just.
So the ground ops has like a official name. It's like called pit mode. I don't know if you want to use that.
Pit mode.
Sorry?
That's more of a racing thing.
Hamza was just saying ground ops as we've defined it here is pit mode. No,
Is what, sorry?
No?
no, no,
No?
no, no.
Okay. Pit mode.
PIT,
That's what I've heard in the past.
like pit stop.
Oh, okay, that makes more sense. It was
I
confused for a second.
don't think we should be able to go from
Alright, guys,
disarm
I'm gonna
to
go.
flight.
Try to get home
Yeah.
before the sun rises.
See.
We'll be home before the sun rises.
Okay.
You don't want to go from disarm to flight.
Sorry?
No, it's okay. We're good.
So yeah, I don't want to go to from disarm to flight because I want to like rotors are off. I think that's the only point of ground ops, right?
There's also a world where like you need your drone system to be armed, but you're doing something on the ground, like.
Like what, sorry?
Like a grabber.
See, the only real case that you can make for disarm to flight, like that transition, is there ever a situation in which you don't need to in which you don't need to be in a ground up state? And if that's the case, then I think it is okay to add that transition.
Yeah.
But fuck, this. What I'm thinking is now this is entirely like it's a new axis inside the state machine. Like how do we just like how are we going to be commanding it between ground ops and flight? Like just for a second of implementation, like how is that going to go down? Is this going to happen through like ground station command, controller command? I just want to quickly prime that.
It has to be able to do it autonomously, and we have to be able to do it as well.
Like it has to be able to do the ground ops part autonomously.
I think maybe we have multiple things to specify an arm sequence. Maybe we have to like press a button on the aircraft and flick a switch on the controller and press a button on the ground station. Controller or ground station can move from ground ops to flight.
Yeah. Do we have enough axes on our? This is an open question actually. Like I think it's coming into the scope briefly, but I think we should probably know like how many axes and how we're going to be mapping those throttles. Annie and Aiden, if you guys are the competition pilots, That's something I would also get started on.
What do you mean by axes?
Like, when you have an RC controller, you only have a certain number of channels that you can actually send data of. 4 of them get removed right away. 5 of them get removed right away because you have your key because you have your, like, you have throttle, pitch, roll, yaw, right over there, and you have disarm. That's 5 axes lost right there. Question is, how many axes do we have? And Annie probably knows the answer to this off the top of his head, actually.
On the actual controller, you have, oh god, you have 1, 2, 3, 4, 5, 6, 7, 8.
Controller probably has like 16 or 32. It's the transmitter that you're more worried about.
The transmitter can do, okay, so PPM can do 1 to 16, but we only got 8 working for some reason. And then SBus and Crossfire can do up to, I think, 22 or 24.
Are we using SBus or Crossfire?
No, not at the moment. If we get
So-
PPM working to 16, it's fine as well. We actually don't even need more than 8 because you have arm disarm, flight mode select, and then you have 4 away. That leaves you with 1 to do this kind of soft disarm and arm.
Okay. All right, it's an open question because if we didn't have that spare channel, then yeah, it would probably start getting messy. But okay, just something to keep in mind because it's starting to come into the scope of how we would do this. But anyways, it's out of the scope of this discussion.
Yeah, there are ways to make it work.
Sure.
That's all we need to know. It'll work.
Cool.
We don't need to worry about channels.
Yeah, I mean, because we are architecting, it's also good to know how. But okay, yeah, out of the scope for now.
So, do we say we can freely move between these 2 modes? No additional checks, like no additional safety checks needed?
I think between when you go from ground to flight, you should do like a basic check of like your level and systems are still okay. But I don't think there should be something that blocks you from going between, because if you're doing this fully autonomously, your software has to say, you know, okay, I'm done flying, I'm in ground mode now. Green light turns off, green light turns on again, and then I'm going to go to flight mode and I'm going to take off. And it should do that on its own. And when you're sort of, if the geography plays out to be badly, you might be in comms dropout for a second on the ground there. Depending on how it works.
I'm not sure actually if we should, like, if we do the basic check, I mean, I think it's just that arrow that moves us into failure state. Like, realistically, I think, like, we should be pulling for that check in every state. Like, even before, like, because state manager has, or like, our system manager has its own controller, right? Because everything can point to failure mode. Like, that's a global check that we do. It's possible to enter in failure mode from any state. It's possible to enter disarm mode from any state, right? So because of that, I think it's because those are global checks. I don't think it's necessary to duplicate and do another set of checks between ground ops and flight, because if any of those checks fail, we should already be in a failure or disarm state. We shouldn't need to actively pull for we're going into flight, if that makes sense.
Really stupid.
Like we shouldn't even be in ground ops if it fails.
I think there should be a way to arm your drone remotely.
Remotely, sorry?
Because if you landed on something and disarmed,
It's a competition requirement. And there's like a physical button to arm the aircraft.
Is it?
Yeah,
yeah. Oh, like on the aircraft itself?
I'm pretty sure it is this year.
Okay, so
Really?
like,
1
you
second,
arm-
to the cone ups we go.
You arm the drone to turn it on for the first time, right?
Yep.
And then it stays in like a drone, like the hardware is armed state, and then you flip a switch and software is armed. Right? But like, if for whatever reason you get bumped or if you land and something happens, your drone remains armed and ready for flight.
Yeah.
If you manage to reestablish your connection with the drone by like moving antennas around, or like for whatever reason you fix the issue, you should be able to continue flying. Because worst comes to worst is the same issue happens again and you just disarm again and you fall out of the sky. I can see a situation where like we lose RC link like we did at competition last year. We have the comms failure that we like code in after like however many timeouts, and we have to like we just can't fly anymore, and that would be like not ideal. And if that's the case, then I think maybe the ground mode and disarm can kind of.
I would say though, so like maybe we don't kick back to disarm mode if we lose comms temporarily, but we do kick
that
back
is-
to ground. Is that what you're saying?
No, I'm saying you kick back to disarm if you lose comms, but if you reestablish comms, you can rearm the software.
You can rearm, but without the physical checks.
Well, I think Annie's trying to make the point that someone has like signed off on the drone physically, right? Because this assumes that, you know, it's the exact same drone. We've the hardware button is still armed, right? We have just put ourselves in the disarm state. So what we're basically saying is that we're turning this into an AND gate, right? Where the button has to be up and you've pressed, or where the controller switches up and you've turned this, and you've pressed this button down and you've held it and it's on.
I think
Wait.
the physical button is like a latching thing. In that
Well, that's
regard.
done in software, right? That can be our implementation.
Yeah.
The button is
Yeah.
latching and it doesn't clear itself when we enter to disarm, which I think is actually pretty fair.
Yeah. I think
Because
it-
someone has signed off on the drone, and you can kill it because it's an AND switch, right? Like, you can kill it on your controller side. If it regains, boom, you're back in.
Yeah.
Yeah.
I'm not sure that's quite how it is. Is it?
You arm the button and then you can turn it on and off and on and off, right? You've done this
Yeah,
for
yeah, yeah. But I don't think there's like a separate arm switch as well on the controller. It's just like turn on the rotors.
That is a software arm. Like when you hit that switch, it does your like you've heard it where like you flip the switch and it does like the sad noise.
Yeah.
It's like GPS not available. That's like the software check doing all the software checks.
Right.
So the buttons are hardware checks and then the switches are software checks. And once both are met, you're good to go.
Okay.
And so
Yeah, so like from disarm, if you've pressed the button at any point and haven't pressed it to disable, and your switch has been flipped on the ground side, you can then transition to ground ops.
yeah.
And so that's like an arm switch. And then there's some other toggle either on the ground station or on the controller to move from ground ops to flight.
It might have to, there needs to be a software toggle on Zerpod as well for autonomous flight. Like we have to be able to arm the drone, like button, controller, hands off, and it does everything on its own.
I think
Yeah.
two buttons.
Well,
Yeah.
So I'm just saying like we toggle a switch on the aircraft,
Yep.
we toggle a switch on the controller,
Yep. And a switch on the ground station.
and then that moves us from disarm to ground ops.
Yep.
Then a button on the ground station moves us from ground ops to flight autonomously.
Also, this way, the judges are like freaking laissez-faire as shit. Like, as long as they see that we're not controlling it and like doing anything, like as long as you do the things, walk away because the drone isn't flying at this point, and then you hit this button and it does everything. Like, I don't think they will care. Like,
Okay.
as particular as they may seem, we all know that like they're very fast and loose with a lot of this shit, and they just want to make sure that that like a human isn't giving the input to get the points.
Do you want to transition back the other way? We're in flight, go back to autonomous flight. Yes. Landing modes.
Yes. Yes. That looks so much more like a proper state machine than everything we've done so far.
Yeah. Wait. I'm curious. Why do we have to end up making that distinction? Like, what benefit do we get from the separate state of like see how the transitions between ground ops and like between flight and autonomous flight are the exact same? What benefit do we have by making autonomous flight a separate state?
You're right, it should be, look on the top right,
Yeah.
0.2.
Oh yeah.
Where?
Nice.
The PM AM question mark event.
PMAM process instructions, get instruction from C ground, decide what to do. Yeah. Okay.
That's like the flight mode event loop, right?
I mean, you can this is why, like, I also drawing out a state machine. If you ever see that all your state transitions are the same, then just ask the question, like, why is it a state?
Yeah. Cool. I think this makes sense. This is good. This lets us turn off the motors without disarming. It lets us operate a grabber without disarming. Disarm, the aircraft will not do anything. Okay. Is there ever a calibration sequence state? Calibration state? To do like.
I figured we'd be doing that on boot, no?
Yeah.
Well, so we do it on boot, but what about like mag calibrations? Or that's the big one really. Compass calibrations. I guess that one's every boot. GPS is every boot. But magnets, or the magnetometer isn't necessarily. They could be like, we're not.
Once every single location.
Yeah.
I mean, isn't that under sensor fuel management though? Like, why is this?
So you're aware of how we have to calibrate magnetometer, right?
No.
You have to like
Walk me
pick up
through
the
that, please.
aircraft and you have to like rotate it across all axes.
I think that should be separate software.
Oh, right. I remember that. Wait, but I thought you only had to do that like if the calibrations were fucked originally. No.
You need to technically do it on each aircraft frame. It might also be important to do it, yeah, like anytime we change the aircraft frame.
Okay. Well then, okay.
And we would have to persist that data as well.
But we have the SD card.
Yes.
Like we can just create a file system for
Yes.
like that can just be where our persistent data lives, and then we're good to go.
That's fine. But I guess the point I'm making here is there may be a situation where we have to pick up the aircraft and spin it across all the axes. And to do that, it's not just like, presumably we move out of the boot sequence pretty quickly. So I'm thinking like,
Or can I really quickly stop before we start drawing more stuff onto here and just quickly ask, is there a reason why the calibration software needs to run in the same context as Zero Pilot? Like, or at least for the magnetometer.
so we don't have to flash new software every time we want to calibrate the thing.
Okay, but
But you only need to do it once per frame, right? Like, I see that as a very low cost compared to the complexity of making this happen and the complexity of having this inside our flight code.
if you needed to, you can make it a compile flag inside the boot sequence with a convoluted board.
So what, sorry?
What do you mean by that?
Like, boot, the comms emulator board will give you the signal that you're, you're good to start calibration. And then you can hit a button on the board and then you can do your calibration there, and then the comms emulation board will tell you when things are done. That's a comms emulation +1.
I think I would still, if we end up deciding to keep it integrated with SM, I think I would opt for more of like a Mavlink approach where it's, or not Mavlink, sorry, like an ArduPilot approach where it's just like all done unified through the ground station, because it's just very nice and clean that way. I would opt for that over a solution that has us plugging in another board. I'm just wondering right now, is it worth it to integrate calibration to our regular like flight stack? I'm not sure what the answer is to that question, but I think that's the question I think we would want to answer first.
How hard is it to flash code again?
20 seconds?
Presumably Zero Pilot's gonna be in a case in like the middle of the aircraft and not visible.
Yeah, but I thought we agreed that there could be like cable extensions.
There should definitely be interfaces exposed for programming, or it's going to be a world of hell. Because think about how you need to program this like a lot of times, even after this goes into the case, right?
Because how else will the comms emulator board talk?
Through the same channels as the existing RC link.
Okay, so those channels are sort of taken out. There's no reason why we can't take out the 4 pins we need to flash, right?
Programming should most certainly be exposed. Like, think about it at competition, right? If you ever need to make a code change, like, you don't want to be opening and closing. Like, yeah, it'll be annoying for you if, like, the programming port is not easy to access under any circumstance. That's a much bigger issue than just beyond the scope of, is it easy to flash calibration software? It should be a requirement of the system that Zero Pilot is easy to flash.
Did you find if the physical switch on the aircraft is required in ConOps?
Yeah. Apparently, so, okay, this is a really weird in their FAQ, okay? In their FAQ, is the flight readiness button equivalent to an arming or disarming switch? Yes. Okay, actually, yes, it is the case. We do need a switch. But that's just a flight readiness button. That's just confirming that, hey, we actually, like, latched the button in there. The latching of the button is still being done in software. That's not being done in hardware, and it's reset on boot. Yeah. So the only way it's on is if someone has, like, actually pressed it.
We should probably do something that checks that to make sure it wasn't on when you booted, because it could have just been against something, and you don't want to let it be armed. If it was
No, the button itself is not latching. The button itself is a push button. You do all of the latching in software.
It's just like press and then release.
No press and hold?
Okay, press, hold, and release.
Right. So
and then in software, it reads that as a latch.
So I'm saying
as if it was like a switch, not a button. Like a toggle switch, sorry.
You want to so that if I start the drone with something bumped against the button, it doesn't go into an on state. Just implementation.
I mean, yeah, I don't think it would. Like if we have a timing requirement on like how long the button needs to be pressed. It needs to be pressed for between 3 and 5 seconds. If it's pressed for longer than that, it doesn't arm. If it's pressed for less than that, it doesn't arm.
Okay.
And then it like toggles a flag in the system manager which says the button was pressed until you press it, like press and hold it again, and then it says the button was pressed again and flicks that switch off. So it's like a software latch.
Okay.
I think like saying the button will be pressed up against something is like we can start diving into rabbit holes about that, but the button itself should be in like a pretty clean space, and you don't plug it in when it's bumped up against something. Like, Annie, you interact with those buttons that we have right now. Like, I'm not sure what you can put up against it that is non-obvious that would actually like hold it down.
I mean, like, I've grabbed the drone a few times and have it like arm or disarm just because I grabbed it wrong.
Really?
Yeah, like more than
The
once.
fuck?
if
Okay. The
someone
controller
else-
should also be off during this time to also clarify. Like, you both of those need to pass for this to happen.
Yeah,
like,
there have been times where other people have been holding the controller and I've been walking and like, you know, like they're walking with the controller and it's swinging around and I'm holding the drone and I hear it arm, like, oh shit, like that controller bumps
Yeah.
at someone's leg and my hand's coming off. Or not
so
leg, but,
that's
like-
that's a problem with us. Like, that's a problem with our like engineering controls that we need to fix. Like, yeah, that's a problem with us, and we can start diving down that rabbit hole. But that's like a problem with our engineering controls of like, okay, we're just straight up not being safe with the drone. But I'd argue that's out of the scope of like SM
Okay.
just yet.
Back to this sort of architecture. What is left to do?
Define exactly how SM does the things. Like, mostly I think it has to do with the communication between all these states or managers is the thing that we need to figure out. And then also telemetry manager.
Are we doing it tonight? Okay.
Let's call it.
I was just saying, there's not much
Bro,
left
yeah,
to
wait,
do.
what the fuck? It's a 112. Dude,
Yeah.
y'all are like, please get some boba or go to sleep.
I mean,
Please.
it's okay.
Annie, don't you? Sorry, go ahead.
It's okay. I have midterms next week.
Yeah, you have midterms. What the fuck?
There's a reason I asked to do it on Friday, not Saturday. Because if we did it
Oh,
Saturday
no.
morning, it would have been the entire day. So,
You.
yeah, okay. I'm going to say we have determined what we need to determine. We have determined what needs to be threaded. We know the event loop inside SM. We have a little bit left to figure out on the implementation specific details of the event loop and of telemetry manager, but we've also figured out very clearly what attitude manager does, what controls is, and how it sort of does the virtual class inheritance goodness, and how we've defined very clearly the struct that we pass to AM, which is the same no matter what flight mode you're in, and I think we have enough to hash out, like we've definitely established enough to know what the basic architecture of zero pilot system as a whole is going to be. We've consciously made the decision to make PM or leave PM as it is, even though it's not the best it could possibly be for a multitude of reasons. And we've knowingly made the decision to sort of give a disarm ground mode for, you know, like ground operations on competition. We also acknowledge that system manager has the ability to wrangle control from AM and PM and give pass-through control directly, or just turn off all the motors if it deems necessary. Aiden is nodding. Okay.
I'm nodding. I agree.
So Hill is nodding. I think that means that this 6 hour, 5 minute, 45 second live stream can come to an end.
Fucking hell.
We can go home and maybe sleep on this for one night before Aiden comes back here tomorrow and starts writing all of the code and testing stuff. Okay.
Do you need help with any of this? Like, is this gonna be a shit ton of work?
It should be okay. I think a lot of it is going to be similar to what we had before. SM might be a little bit more work than we originally intended it to be, but AM should, AM's also gonna be a lot more. It's okay, it'll get done.
Okay.
I think
Yeah.
it'll be easy to set up like the boilerplate.
If you can
Yeah,
get the
like-
boilerplate set up in a way that is easy to understand, I can have Jack go ham on all of it.
In my head, I'm imagining like I'll be able to get the boilerplate for Attitude Manager done.
Okay.
I doubt, because we haven't really figured out how these pieces are communicating with each other, it's gonna be hard to do much else. Like I could set up the state machine for SM. I don't think that would be difficult, but beyond that,
Are mail queues owned by people?
Mail queues? No, mail queues. Mail queues have no sense of ownership, to my knowledge. They're basically built on top of semaphores. They just have like a queue buffer, and then semaphores count the index, and they just go through and jam. The disadvantage of a queue, though, is you don't want to accidentally process on old data. So say for some, you don't want to process on old data. Queues are useful when you have something that needs to be processed in real time. So, for example, imagine if you wanted to use a queue for like your button or something or like there's like a really high priority message coming in from the Jetson and you don't know when it's going to be coming in. You can use queues to process those, and if they need to be processed in a particular order. If we care about processing in a particular order, then queues might be helpful. Then queues are correct, but I'm skeptical about them being correct in this particular situation because we might be processing old data, if that makes sense.
yes, it makes sense. I'm not sure.
Maybe if
But-
we go and take a look at what the options are and then just pick one.
What, sorry?
What the options are.
Agreed.
Like it seems.
I think you can sorry, go ahead.
It seems to me, no matter what we do here, like the data is going to be a little bit stale. Like, Attitude Manager is gonna get its input, and that'll come from System Manager, and System Manager needs to send that at some point. And if it's a queue and it's old, well, what if we just were flushing the queue? Essentially, like we read every single component or every single item out of the queue, and then if there's nothing left, we just process on the last one, basically.
So then why are you even using a queue at that point? Just use a synchronous interface that takes the latest data, as what we currently do right now.
I agree. What we currently do is not thread safe at all. Like not even close.
We can make it thread safe. Like we don't need to return raw pointers. Like the easiest way to do it is just literally like the typical design pattern is you have data or you have a data return object, right, that has all this, and then get has you just basically pass a reference that this higher level module calls, and it goes in and it comes out, and then that way you don't have to deal with any sort of like weirdness that comes into it, and each module that is responsible for giving data away just implements a mutex around that shared data. And so then that way, when you copy it, you're not going to be dealt with like weird situations of like, oh, well, someone was modifying sensor fusion, like say sensor fusion itself was trying to modify the data as it was being copied and got preempted in there. So a mutex is a good way to solve that. If you're really, really, really scared about real time, semaphores are a good way to do this. Like, for example, our arm disarm thing should probably be implemented with using semaphores. because it's the highest priority thing that we want, and we can set tasks that block on a semaphore, and as soon as they unblock, the kernel automatically switches to them and it executes code that moves us into the disarm state, and that's like the number one thing. So even if we're hung up on the thread, even if we're hung up on anything else, or if other tasks might be scheduled to go, we can use semaphores to our advantage. So if you care about really processing the data as fast as possible, you can use semaphores, but then you have to be very careful about the real-time design aspect of your program, which is honestly like, we don't need that kind of precision.
Cool. Cool. I think we'll just call it for now, and then we'll come back to it tomorrow. Yeah.
No, that's a good idea. It's 1 a.m. for y'all.
Yeah. All right. Bye, Sahil.
See ya. Have a good evening.
You too. Bye bye.